Thank you, Wendy, and I'm entirely out of time according to the schedule at the moment. I will be brief. So, as Wendy said, I joined here in 2016, and immediately Nick left. It might have been a consequence of me being his postdoc in the mid-90s, but I sort of feel, although I joined in 2016, I feel sort of ECS at Southampton is something as a sort of a second home in now it is my proper home. Because I had research projects with colleagues in Southampton continuously from 2000 to 2016 when I jumped ship and came here. So I've been collaborating with people like Nick, Nigel and others in ECS for many years. So ECS is an innovator, essentially. It's the first university to establish a self-archiving mechanisms back in, 2001? I'm sure all this will come out later in the subsequent talks. And now this is sort of open access, is mandated across the UK and many other countries in terms of enabling access to data from research, but also open data in government. And Nigel, I will leave you to talk about that. Why are we here? So we are here to celebrate, CS at Southampton, but also to celebrate the fact that we were given the first Regis Chair in computer science. So this is the country recognising that CS is a sensible subject and it's here to stay. So that was back in 2013, and Nick Jennings, who will talk later, had that chair, and now it's passed over to Wendy in 2017, Dame Wendy Hall, who everyone knows, as she said. There are loads of research strengths within computer science in Southampton. I mean, notably web science that has been going for many years. AI and machine learning, cybersecurity, formal methods in computer science and software engineering, Internet of Things, cyber-physical systems. But I think the key thing that makes ECS stand out, a lot of computer science departments talk about this, but ECS really sort of leads and does it well. And that is interdisciplinary collaboration, whether it be through the Web Science Institute, across electronics and computer science, with engineering, etc. And there are a large number of research activities that you will find out today, but also ongoing things, so active things like the Trustworthy Autonomous Systems Hub, which is a major new investment within ECS. So I have given my welcome. Our next speaker is Judith Bishop, and we have Professor Tony Hay, Dame Wendy Hall, Dave DeRoore, etc., etc. So all these fantastic current or past ECS members talking about their research, their experiences. So a very warm welcome to all of you here, and a warm welcome to Judith, who's come.
I'm going to introduce Judith.
Yeah.
I just wanted to say something else. Thank you all for coming to this. Lovely to see new faces and some of us ancient ones. The purpose of this is really archival. It's to record, and there's Adrian Pickering sitting in the front, and Joyce here have been helping us with the history, because it gets lost so quickly in universities. A lot of people won't know the history. And when we decided to do a Regis Chair, when I asked the heads of department, it was Paul and then Tim, if we could do a annual Regis Chair lecture, it doesn't mean I speak every year. I may be the Regis professor, but the chair is the universities. So it's mine temporarily until I leave. It was Nick's temporarily till he left. And then there'll be another, it's like a bit like a monarch. Except we do take a while to elect a new chair. It's not instantaneous, but there will be another and another. So this is something, and this is it here, signed by our great Elizabeth II. This is the charter we got from the palace, went to the Vice-Chancellor, and then it sits in my office. And but this is it, right? And we're proud to have it. And when you say the first, it's the only, and I've got no idea if there'll ever be another one. So it's pretty unique. There is only one. Most of them were in classics and medicine and things, history in Oxford and Cambridge, and the Queen, or her advisors, decided they would recognise more modern subjects in her Diamond Jubilee. So that's when that was, and we produced a document. Anyway, enough of that, I'll talk a bit about that later. So this is archival, and of course, as we know, the University in its wisdom has just wiped most of the archive stuff off the web. We've got to retrieve it and make sure we keep it in perpetuity. This is the great One Web project. It's one way to get rid of the web project. So we all that stuff. But this is we have David Barron's ex-augural talks, which are still archived, aren't they? So we're going to work with the library to do this properly. It's now my pleasure to introduce Professor Judith Bishop. She and I did our PhDs together. That's why I wanted to introduce her. She was in computer science, I was in pure mathematics, and David Barron was a common theme in that. I'll leave Judith to say her own reminiscences of that, and what made computer science here become so special enough to get a Regis chair, is what the theme of this event is. So Judith, all the way from sunny South Africa, welcome.
Thank you, Wendy, for inviting me, and to everybody for coming and being here, because I think this is very important, and it's wonderful to see so many of my ex-friends here. Well, you're not ex, but my friends. So I'll wait for the slides and then we'll get going. So Wendy gave me the title of the glory years, so I thought that was wonderful. The glory years took place in the red circles and the yellow one. There's the Maths Building, the Students' Union, the library, 131 to 135 University Road, and the Crown and Sceptre, which was the yellow one. So that was where we hung out. Now, in the late 1960s, computer science was starting up all over the world. And I was incredibly fortunate to be in the beginning of one of the classes at my university, which was Rhodes in Grahamstown, South Africa. Looking back at my class notes now, we had a pretty good and thorough grounding, though there was rather too much numerical analysis for my taste. We had operating systems, compilers, languages, and they were the hot topics. The following were yet to come: networks, graphics, artificial intelligence, and databases. We hadn't heard of those. When the time came for me to embark on a PhD in 1974, there was no question but I would go to the UK and follow many of my friends before me. The cities that were on my list at that time, looking from the north down, were Edinburgh, Newcastle, Manchester, Cambridge, Imperial College, Queen Mary College, and Southampton. I was accepted at Queen Mary College and Southampton, and Queen Mary College wanted me to work on microprocessors. That was a new thing in those days. Think about it, 1974. But that sounded too much like hardware, and also they didn't sound like they knew what they were doing. So I already knew software was my forte. So I chose Southampton for three reasons. Firstly, I knew from my geography it was the furthest south and was likely to be warmer. Secondly, it would be cheaper than London. And thirdly, David Barron was there. Now, David Barron was famous in our university in South Africa for writing textbooks that were short, totally understandable, and unlike any of the other books that we had to wade through in our degree. I also had the pleasure of meeting David at the end of 1971 when he was part of a group of professors from the UK sponsored by IBM to teach the teachers in Stellenbosch. That's one of the Stellenbosch mountains there. Even though just a student, I managed to wangle my way into the event. And at this point, I'd like to say to any students in the group here, wangle your way into events if you can. My professor, when I asked him, said, well, faint heart, never won fair lady, I shall ask. And of course, IBM said yes. So that launched me on a career I could never even imagine. So just ask. Now, I was captivated at that time by David's introduction to comparative programming languages, which he presented. I also embarked with David on a measuring exercise as to the effect of drinking Campari on pig socks, but I won't go into that. You can ask me about it at tea time. Now, in his acceptance letter on the left there, David said we would work on software engineering. I had no idea what that was about, but it sounded modern and it sounded right up my street. So there he said the aim is to investigate in a quantitative way the cost in terms of processor utilization and store capacity of various features in high-level programming languages as actually implemented on computer systems. Great, I thought, all right. I arrived in Southampton in early September 74, so do the maths, and to be met by two very friendly members of the JCR. After 2 weeks camping around Cornwall because I was early for the start of term, I met the computer. At those times, universities had one computer to rule them all. The ICL 1907 was huge. It lived in air-conditioned splendor in the Maths Building 54, watched over by operators like in a nuclear reactor. As time went on, heavy users could gain access. I was one, good. I remember making friends with some of the geographers and chemists on the night shift. They were very keen to use some software I'd brought with me that activated the graph plotter, which was an immense long thing that went round and round and round like that. My years at Southampton were, as David promised, involved with writing compilers and measuring how well they performed. More particularly, I was concerned with code generation. Our language of choice was brand new, Pascal, and there were very few compilers. The first one was built at ETH Zurich in Switzerland for a CDC computer, which was completely different. However, a very clever group at Queen's University Belfast had adapted this compiler for an ICL 1900 series, just like this one, and I was detailed to fetch a copy. So I flew on a single prop plane to Belfast to meet Tony Hoare, later Sir Tony Hoare, and Jim Welch. Amid the sounds of guns going off in the streets, they copied the compiler onto a 7-inch tape, and I flew home the next day as fast as I could. Because our computer had its own operating system called Coop, some of you might remember it, it took a while until Pascal was up and running at Southampton, but students were soon learning programming from the master craftsman, David. David had handed over the directorship of Computer Centre to Morley Sage, who was not very pleased with us. Well, I don't know what he was pleased with, but because the student Pascal jobs took longer to compile and run than those on Wat4, which was the fast Fortran compiler. That spurred me on in my endeavors to find out why and whether Pascal could be made as fast. I became obsessed with measuring code. How many instructions, how fast did they execute? And this was the subject of my thesis, code generation for structured architecture. As with all PhD projects, and I'm sure those of you out there will know this, nothing was plain sailing. To get my measurements going, I had to adjust the interface of the Pascal compiler, and the advice was to employ SIDS and SAGs. acronyms, don't worry, on a Pascal grammar and proceed from there. These tools had been devised by members of research teams in the military establishments at RRE Malvern and at the Military College of Science in Shrivenham. I met Peter Foster and John Hunter, shown here, at an EU compiler construction course in Munich. We went to the opera and I fell asleep, I remember. I visited both Peter and John in the summer of 1975, struggling to port unfamiliar and slightly incompatible software across to the 1907. It was interesting that in my report shown here about what I did, because actually I had to spend money of the departments, all £2.94 of it, so I wrote a report. I said I was met at Swindon Station by an army chauffeur and treated to lunch. The whole day cost their money for the return ticket. And I also acquired another manual which fell off the back of a bus. So there it was. In my second year in Southampton, there was great changes. Computer studies moved from the maths building to 113135 University Road, and the 1907 was removed and a sleek 2970 replaced it. This was part of an industry-university collaboration, and we had to write software for that, which they were going to perfect and then sell to their clients, which was a great idea and the kind of thing which you're all used to nowadays. They wanted a Pascal compiler, and Andrew Hutt was helping them to do that. He was one of their employees. The ICL 2970 wasn't favored by researchers at the university because it was different to the usual Fortran type IBM machines. It had a stack for efficient instruction execution, and it had descriptors for quick access to arrays, stored in row order, not column order, which Fortran used. As an example of a structured architecture, though, it was fabulous. And I could delve into the proper use of stacks, displays, descriptors, tags, and my thesis raced along. I finished in the required 3 years. In fact, at that time, all of us did. I don't know if it's the same now. And at the end, David and I were able to publish 2 papers in the Computer Journal. One drew the ire of our friends at the UMIST because they thought we cast their homemade computer, the MU5, in an unfavorable light. We did. So, during that time, David and I got on very well. We both wanted to proselytize, that means advance, new languages for teaching and research. In 3 short years, we ran 2 symposiums and wrote a book. And the symposium on Pascal brought famous people from all over Europe together for the first time to talk about Pascal. It fired up the Pascal users group, and together, David and I were able to write this book on advanced programming, which was used here and all over the world, actually, for better writing of programs. It was sort of a data structures book. At the same time, of course, Southampton wrote itself into the record books twice. In 1976, the Saints won the FA Cup final, and joyous crowds welcomed the victorious team. We all turned out to watch the bus along Burgess Road. In the same year, we enjoyed a record hot summer, familiar? With temperatures above 35. Admittedly, there were standpipes in some areas, but it was the era of universal good humor. I don't remember complaining. Funny. We also had, at that time, a wonderful time as students. We got on so well between the students and the staff. We had the Institute of Futile Research, and we ran a symposium where everybody had to speak about stupid things. And we had posh dinners. Peter Landsberg was part of that. And on Shrove Tuesday, we even had a pancake race around the university. Yep. Those of David who will remember him is that he had a ready wit, and he was happy to express it in print. He would write to the Times Education Supplement pointing out misquotes and failures, and we lived in this aura of excellence and free expression. When it came to reread my thesis recently to fact-check this talk, I blushed, and then I laughed out loud at how forthright I was in expressing my opinion of the work of others. In contrast, the papers I review these days are far more muted and polite. I mean, it is horrifying to note, I said, or misplaced faith and unwarranted fear. And these procedures are set as an exercise for the reader. Come the 70s, interest in code generation was focused on the desire to do as little of it as possible. Apparently, quite accepting, David announced as he finished the Viva and reached for the Seri that I'd received my PhD without any changes. So that was just as well, because my friends were waiting in a car outside to take me to Heathrow, and I was off back to South Africa. 8 years later, I returned to Southampton for a year's sabbatical. Between times, a tsunami had hit the programming landscape in the form of a new language from the US military, which was given the dignified name of Ada. I'd been following the language carefully. Ada had two deficiencies, however, immediately apparent to language gurus, and keeping up with the times, there were no generics and no concurrency. In 1986, computing was still focused on large mainframes, though, and the challenge was how to have different parts of a program running and communicating simultaneously. A paper published in '87 in our favorite journal, Software Practice and Experience, which David was editor of, co-authors were David Pritchard, now deceased, and Stephen Adams. I'd like to just pay a bit of a tribute to Stephen Adams at this point, because he's someone famous from this department whom often gets left out. Stephen arrived in '86 from the University of Witwatersrand, where I had worked. He was employed and stayed until 1991. In the first couple of years, he was staff, and he worked on a project trying to do automatic program assignment assessment. Eventually, he qualified to get a grant on residence criteria and went full-time as a postgraduate student. And those were the glorious days of publicly funded education. You didn't have to pay anything. Like me, Stephen was always interested in programming language implementation, and to narrow in on a PhD, he looked into ways of building a language from components, submitting a thesis on modular grammars for program language prototyping with Peter Henderson, who's shown there on the left. This was an early picture of the computer studies group. You can see some of the people there that you might recognize. Stephen had a very distinguished career thereafter in the United States, which is why you probably don't know much about him. And he worked as a research scientist at MIT for 5 years on amorphous computing, and then went on to work at Microsoft Research, which some of us also did, where he worked in static analysis. And one of the problems of his group was to tackle buffer overruns. They deployed a tool that could generate and check annotations that made C-level code safe. Another tool they wrote found programming mistakes in the kernel and allowed privileged objects to become accessible from user mode code. Stephen now works at Google on Dart and Flutter. Many will remember the dark days of buffer overruns in Microsoft code. The ICL 29 series with Pascal and Ada were aimed at avoiding all of that. But unfortunately, the cowboy freedom of C, together with Windows and the IBM's PC, took hold. I came back to Southampton as a reader in '89, which is where I met perhaps many of you seriously. And the new Department of Computer Studies, but the whole world had changed again. David May had started manufacturing transputers with verified hardware, and Tony Hay here was keen to make use of them, as was the whole CS department. Suddenly, we could distribute parts of a program onto chips that were built to communicate with each other. Distributed Ada took off, and the hope was that despite its complexity, Ada would become a really useful language. The third in the series of symposiums was held, and, oh, by the way, I did remember that the dinner for that was at the medieval banquet at Bewley. And maybe some of you remember. On Distributed Ada, the proceedings came out as a book, which I edited. I left this great university at the end of 1990 for personal reasons, but continued my association with visits in both directions, notably by Dame Wendy to the University of Pretoria. Can you believe that everything I've recounted was accomplished without any of the technology we take for granted? And we did a lot. We made languages happen, we made compilers happen, we investigated hardware. The UK pioneered email with Janet in 1984. TCP/IP was available for 83. Dame Wendy invented hypermedia in 88. Sir Tim Berners-Lee launched the World Wide Web in 89. All of that is before what I'm talking about. Sorry, after what I was talking about. And in 1990, I had a Mac at the office, which I would carry home to Westridge Road on a bus like this, right? But it wasn't connected to the internet or anything like that. Dial-up came later. So, to compensate, however, for all of that lack of technology, we did have reliable and cheap mail and rail services, which we took for granted, I must say. So the legacy of the glory years has to be the people who went through them with me and others. Many speaking here, to the books, in the attitudes towards scientific and human endeavor, and in the fact that Southampton is without a doubt a top university in the UK. I feel honored to have been part of the glory. Thank you.
I would give that credit to Ted Nelson, who I'm actually going to go and see in October. He's 80-something and still alive and kicking. So, still alive and kicking, Professor. Tony and Jessie and I have known each other since the 70s. Yeah. In fact, you used to muddle me up. Yeah, but I met you in 70, when I was going out with Mike Pelham. 74. He used to muddle me up because I used to go out with a guy called Mike Pelham, who was in the squash team, right? Yeah. Yeah, so he used to buy me drinks because I was with Mike. Then Mike and I split up and I met Pete, my husband, and I came back into Tony's life as Pete's girlfriend, and he was very confused for a long while. Anyway, we still had to buy me drinks though. So we have known each other a long time, but of course then he becomes, would you believe, by then, well, I'll tell you my story in a minute, but he became a professor in ECS, Professor of Porter Cabins, we used to call you. And because that's what we had. And he then became my boss as head of department. Anyway, I'll leave him to tell his own story. Tony, it's wonderful to have you back here on campus, and the floor is yours.
Thank you very much. Very good. Very good. So thank you very much. It is a delight to be back here. And I was looking at the list of speakers, and my career has interacted with all of them except Tim Norman, so I'm delighted to meet Tim now. But what I'd like to do is tell you another chapter of the history, which is, I don't think, as well known in the UK as it is in the US. So it's about the group. When I joined this department, we were stuck in some porter cabins by my then head of department, Professor Henry Kamajim, and we were known as Professor of Porter Cabins, but we nonetheless did some interesting things. So let me tell you then about the concurrent computation group, which incidentally I named our youngest son's initials are CCG as well, just so you know. And I'll pick up from where Judith left off with transputers, Occam, and the contribution that this group and this department made to distributed memory supercomputing. And it's significant, but not well known in this country. So you have to look back to the early days of the 80s. This is a Cray XMP. The seat there used to be known as the most expensive seat in the world, $15 million. But peak performance is less than your phone at this moment. But it was 800 million floating point operations per second, known as megaflops. Okay, but in 81, I went on a sabbatical to Caltech, and I listened to this guy who gave a seminar. It was a very interesting seminar at Caltech. All the staff was in a room like this, and he'd forgotten about it. It was a faculty seminar, and so they dragged him out of his lab. He came with a box of slides in those days and gave a fascinating talk where he revealed that his analysis, which was explaining Moore's law, predicted that there were no engineering obstacles to microprocessors getting smaller, faster, and cheaper for the next 30 years. And he was wrong, of course, because it was more like 40 years. But nonetheless, it made a big impression on me. And I was visiting a friend of mine, Geoffrey Fox, who was also at this lecture, and we didn't talk about it. But when I left, he was building this, which is known as the Cosmic Cube. These are essentially PCs. These are Intel PC microprocessors in each of these, and they're connected by a hypercube network so that you could send messages between these. And this was, instead of having a shared memory on a supercomputer, you had just distributed memory, and you had to do calculations here. You had to break up your program in pieces, do some calculations, exchange information with your neighboring processor, and carry on with the next part. So you had to organize how to program it. So this is Geoffrey Fox and Chuck Seitz with their first hypercube supercomputer. And this could outperform, not a Cray, but it could outperform a VAX in those days, 11780. So I was also stimulated by Carver Mead's talk, and I remember I decided on a whim to go and listen to this man giving a talk at the Royal Society in 1983. And it was on transputers, how you could easily connect these things together. Dead simple. You could build a huge array of these things and it would just work magically. And of course I believed it, which was a mistake, but nonetheless, it turned out to be a good thing. And then on the weekend, on the Sunday, I was flying to go and collaborate with a friend of mine in St. Louis. And on a TWA flight, and TWA doesn't exist anymore, it turns out that Inmos, who he founded Inmos in the UK with some US venture capital, and one of their fabrication plants was in Colorado Springs. So he was on his way to Colorado Springs on a TWA flight which stopped in St. Louis. And there was I in economy, of course, and there was he in economy in the middle section. So I thought, well, this is ridiculous. Obviously, fate has brought us together. I'll go and sit next to him and ask him for some transputers. And they hadn't made them at the time, and there was great skepticism that they would ever make a processor, because they'd made memory. They'd made their money by memory chips, and they were now moving on to microprocessors. And his statement was, when I was explaining how important it was to solve quantum chromodynamics, all right? This is the theory of the strong interactions. I was a particle physicist at the time. All I needed was a big computer. And so he said, well, if you can have them, if we can make them, you can have some. And this is what it looked like. It was an innovative machine in that it had a processor and a floating point coprocessor all on the same chip with a large amount of memory, and then links which enabled you to connect them up very easily to other chips. And I remember going, with Inmos's permission, to Europe. They didn't know anything about European projects. I went to a European meeting in Brussels in '84, and in those days, European projects were very taken up by, maybe you don't remember, functional programming, data flow, and all. That's all the things they were interested in. There was nobody interested in doing numerical computation on large parallel computers. And so nobody was interested at all. Nobody listened to me. They all laughed when they said, you know, floating point transporter, 28800, they can't build a non-floating point transporter. However, thanks to someone who was later charged as a Romanian spy living in Grenoble, I managed to get a partner who managed to bring up some companies, and we were able to put a project called the Supernode in 1985, and we were approved, and we led the architecture and the applications package. So Chris Jessup, Dennis Nicol, Mike Moore, Charlie Askew were among the people, the first people who really started the hardware aspects of it, and Jeff Reeve and David Pritchard, who are both no longer with us but were members of this department, helped me with the applications package. So that's what we did, and over the next years, the whole emphasis of the European program changed to doing numerical calculations on supercomputers rather than AI and stuff in those days, in the early 80s, functional programming and so on, which did not deliver very much at that time. And what we had success in, there were several companies producing transputer-based machines. One was an offshoot of InMOS called Mako. This is one of their computing surfaces. There is now a computing service. It comes from an AI chip called Cerebras. It's a whole wafer, not a chip, and that they call their machine computing surface. I had to remind them there used to be one called Mako. And this is one of the ones that we built, a Parsitech supercluster that was commercialized. And in 1990, I went on another sabbatical, and this time it was to IBM Research in Yorktown, and they had several parallel computing projects funded in the terms of millions of dollars. One was called the RP3, the other one's called the GF11, and they both essentially failed, right? Nothing came of them. But there was, the reason I went there, I was in Fran Allen's parallel programming group. She was interested in parallel Fortran, by the way, was because they had a black project called Victor. And Victor was just something people had cobbled up with spare bits of money floating around to build a message passing system, rather like our Supernode project. And that's what they'd done, and they programmed it. And what they managed to show to the IBM hierarchy was that you could do real stuff with these message passing machines. And so the IBM hierarchy became convinced by this transputer machine that this was a sensible way to go. And instead of commercializing RP3 and other things like that, they actually commercialized what's called the SP series, and this is an SP2. And because I'd worked with IBM for so long, IBM US gave me a SP2 to run, and I managed to persuade, it wasn't Morley Sage running the computing services, but I managed to persuade them to run it as a computing service, and to this day we have parallel computing run by the computing services. So this was the SP2, which we had in our group, which I gave to the university to run, and worked with IBM Hersley to see if we could run some of their software, because they were known for their transaction processing software, probably the best-selling software of all time, which you all know the name of. CICS, yes, CICS, nobody knows it. It's all your airline bookings, hotel bookings were all done with CICS, and it was a project that IBM Research Labs are curious things, because there's a rule that any IBM Research Lab in the US trumps any non-US research lab. So IBM Silicon Valley wanted a project that was held by Hersley Lab, and they swapped it for one of their projects. The project they wanted, they gave to Hersley, was a project they thought would die, which was CICS, which turned out to be the best-selling software of all time. And the project they got back instead was really much more valuable. It was the PL1 compiler. Which, okay, so I had an SP2, and because of that, it came from the US, but the UK salespeople had nothing to do with it and didn't get any money from it. So I didn't have any money for software, and they didn't give me any software, so we had to cobble together bits and pieces. But because I was on a list of having large IBM machines, the only perk I ever got from them was actually a ticket for 2 to the Atlanta Olympic Games, which we went. And we discovered IBM is famous for having no alcohol on its sites. Except in France, you can have some wine with your lunch, but that's about it. So when we got there, we found that Atlanta Olympic Games has these sponsors, one of which was Coca-Cola, I remember, and they have these parties and they pour lots of champagne in you. And IBM needed people to come and drink their champagne, so we felt we were doing them a service. Then a sad thing happened. Inmos got very scared by the projections that Intel were making for their performance of their chips, and they tried to do something that was too difficult. It was too big for their design systems. It was a T9000. This is actually the only T9000 I've ever seen. It's in Jim Austin's computer collection up at York, and I haven't actually seen it for real, but I must go and see Jim and see if I can see it. But it was failure. My project officer in Brussels, Thierry van der Pil, said, I don't mind paying for the T9000 once, but I do object to paying for it 3 times. And they never delivered. So it was sad. So in the early 1990s, there were many, many machines. It was a time of lots of experimentation. These are just listing some of the machines that were out there. And each of them had a slightly different way. If you wanted to run a program on this machine, you had to rewrite it to run on another one. And it was all rather trivial things, but it was stupid there wasn't a standard. So what we tried to do was, this is Turing Award winner this year, Jack Dongara. This is his collection in his office of failed computer companies, basically, the mugs he's collected. And you can see Mako's there, all right, and Silicon Graphics and a few others. Maspar, Thinking Machines, and so on. So the question is, could we make something better? And what we managed to do was, there was a difficulty because Europe was going one direction, the US was going another direction, and it was needed to get something together. So what we did, we convened with Jack Dongara and another European, Rolf Hempel, and David Walker from then at Oak Ridge. We wrote a first draft of a standard message passing, how you send a message from this processor to this processor and acknowledge and all that sort of stuff. And having a draft was very useful. We presented it at a supercomputing conference in Minneapolis, and having a draft was really good because lots of people disagreed with it, and they all had ideas and they wanted to do things. So it really got people going, and people like Mark Sneer from IBM, Jim Cowney of Mako and Intel, were key in the standardization. You had to go to Dallas Airport every month and sit in a hotel and not see anything else. So it was really hard work to do, but nonetheless, this standard is here today. It's not endorsed by any standards body, but is used everywhere in supercomputing. And Bill Gropp and Rusty Lusk were responsible for producing an open source version which would run on day one on your new machine. And then the companies produced their own versions. So just to finish up, then you want to run machines on it, programs on this. Well, people were saying you had a benchmark, and I was very interested in Judith doing such benchmarking computers. I hadn't realized that she'd done so many benchmarking. Well, they had this perfect benchmarks, and they were just huge, large Fortran programs. And of course, in order to run that on a distributed memory machine, you'd have to break it up and do all sorts of things, and that was not possible to do. So we produced what were the first standalone distributed memory benchmarks, which were low-level applications, application codes, which you could just run straight away. And we initially used PARMAX, but we converted them to MPI. And then I wrote a paper with Jack Dongara about how you needed to characterize a parallel machine. You had to have more than just one number, right? And this is the paper we wrote. It was called Parkbench, Parallel Kernels and Benchmarks. It wasn't just a joke. And this is the paper we wrote. And this is, of course, what happened. Jack Dongara was seduced by a German professor to do he does linear algebra. AX equals B is what he does. Spent his life doing AX equals B in matrix multiplication. And this is the standard that's now used. And you can see how the performance has gone up over nearly 30 years, 25 years or so. The top performance, and then the bottom performance, and the average, and so on. So it's remarkable, and what the other slide shows you is how the different architectures and different chips have done. So it tells you lots of stuff. Even though it isn't adequate to benchmark a machine, it actually is useful, and I was clearly naive and wrong in understanding what marketing people want. And so it was really good. We were doing really well, and then I became head of electronics and computer science. and the rest is history. Yeah, well, so anyway, I had a great time here, and I was fortunate enough to interact with many of the speakers today, and it's great to see that the department is still thriving, and I'm honoured to be a member of this department. Thank you very much.
Yeah, it's true. And I was actually going to tell that story this afternoon. No, because Muffy Calder is from Glasgow. And she was offered a chair here. Did you know that? No. And she turned that down, and I was offered a chair in Glasgow, and I turned that down. Anyway, there you go. Right, so I just threw a load of photos together, basically, last night, after the funeral event. So this is not very well prepared, but hopefully it will just trigger some memories and help me tell my story a bit as part of the glory years. Well, the glory years, Judy described until 1990 when she was here, but actually I felt it's all gone downhill since we got the Regis chair, and now we're picking it back up again. So that's, you know, we actually, you know, we were the top computer science department effectively in the UK for a while. We were like second in the ref and all that sort of stuff. So it was a mammoth climb from the group the picture I'm going to show you in a minute. So this is me. Did my PhD here. That's my husband. In fact, that's his PhD because he's a year younger than me. He's my toy boy, as he likes to say. This is a very personal perspective. I think we've all done that. We can only tell the story from our own perspective. So here we are. This was the Computer Studies Department in 1984, as I recall. I joined in January because I did my PhD as a pure mathematician, went off, couldn't get a job as a pure mathematician, came back here as a computer scientist, having taught myself BASIC on a Commodore PET on the way through. And as Dijkstra said, I was mentally mutilated for life. There you go. So, as I recall, it's on from the left, Gwyl Edmonds, Mike Freeston. This is the guy I replaced. I can't remember his name. Did you recognise him, Judith? I didn't really know him because we overlapped by about a month or something, or no, maybe a few months anyway. Can't remember, it was David's, I think he went to Durham. Then the great David Barron, Mike Rees, Ken Thomas, who I was hoping might be here today, but I don't see him. Fred Smith, who was just a great statistician, one of the country's best, and taught so many students here, including Ian Diamond, I suppose. And he was Dean of the Maths faculty at the time, and we were then, we were part of the faculty, but we became a separate department. So as I joined, we were part of the Maths faculty. We say that, we stated we were celebrating becoming a separate department. We had just launched a computer science degree. I think by the time I joined, is Tim Chow? No, of course he's not here. He doesn't work anymore, Tim Chow. I'll show you that picture in a minute. Then it's Ros Austin. Who remembers Ros? She used to run the IT systems, and she was terrifying, right? Absolutely terrifying. If you did anything wrong, you got kicked off the system. I remember when they were playing football one night. Remember? Oh dear. Anyway, she banned everybody for a whole week, I think. Anyway, she's still around. I still see her or exchange Christmas cards with her. And Jill Lovegrove, she was a lecturer here, helped me a huge amount, and there were very few women then, as there are now. I've lost touch with her a bit. She went up to Sunderland to be head of department. She was quite well known in the UK computing. But I've lost touch with her, so I didn't know how to invite her to this. But that was the department. And that was, this is a story of parties, actually. This was us in the pub. I think that was the Highfield of it wasn't the Crown Sceptre. I think it was the Highfield. Yeah. So when you said that was Peter Henderson in your photo, Julie, I've got the photo. That was actually Paul Garrett that you highlighted, yeah. And behind Paul, I think that's Sebastian Rots. Dave's going to talk about him a bit, isn't he? He was our first interdisciplinary lecturer, joint between archaeology and computer science. David Barron made that happen. He was really more of a sysprog than I learnt all about a multimedia, published post with Sebastian about looking at headstones in the Protestant cemetery in Rome with all the poets. I mean, God, you'll still find, do we still do latex here? I have no idea, but you'll still find memories of Sebastian there. Everything was called after Lord of the Rings. But he went off to run computers at Oxford and unfortunately died far too early. And then on the left is Mari Turner, who was our group secretary. And to the left of her, is that June? I don't know if Susan knows her. I forget her name. She was the maths faculty admin person. And Mari, amazing one, was our CS department secretary. She was wonderful. Now, this is a larger group. In those days, we had, now I can count, there were 3 PhD students here. That's the whole number of PhD students we had. So there's, I don't know, can I point with this? Yeah, so that's Paul Farrow, that's Rod Crawford, and this is Count Hugo Yankovic, who was they're all quite amazing. But Paul, for a while, when I came back to Southampton into computer science, Paul was the only postgrad. We had one postgrad, and he was a postgrad with David Barron. The rest of us didn't have postgrads. I used to say to David, get me a postgrad and I can do much more. And he'd say, well, we don't have many at the moment, but as soon as we have some applications, I soon started collecting them, of course. There we are with the same, you can see we're here this is the back room, as this one was. Not that one. This is the back room of 131, 135 University Road. That was our seminar room. So that's with some of the undergrads. Now, Tim Chown, I think he graduated with the first cohort computer science students. And I was his tutor. He never let me forget that. He went through 3 tutors, they each one left, but I stuck. I was his tutor in his 3rd year. I knew nothing about computing. I mean, I was a pure mathematician, right? So I was really learning on the job. And what's the next slide? Oh, well, this is more. So I'll tell you, so basically when I came back, I might as well tell you now, in those days, you didn't get this sort of namby-pamby, you get half a term or a term to, but, oh, Eric, hello. You all know Eric. You didn't get time to prepare your lectures and think about what you're going to do and set up your research. I started the job on January the 1st, and after the exam, so 3rd week of Jan, I was teaching Pascal. Using this book, Student's Guide to Programming in Pascal, and I was remembering this last night. It was quite a famous book at the time. Tim said you actually considered it for, did we say Atkinson was from Sheffield? But anyway, the key thing was that it was quite a good Teach Pascal book, but it was accompanied by a set of videotapes. And he played the guitar. So every one of the videotapes started with him singing and playing guitar. And then he went through a chapter of the book. And I realised at that point how wonderful online multimedia teaching was. Because all you had to do was go to the back of the room, put the videotape in, and sit down and twiddle your thumbs till it's finished. And then you set an exercise. And I have found in here, I was showing it to Les earlier, this is in my cupboard in my office. There's a set of exercises that I set. And it was running on release height.pass. And there's some instructions as about how to get that up and compiled. And I used to do all this sort of stuff. You wouldn't believe it now, but I did. So it was wonderful. You just played the videotapes. It was fabulous. And of course, there was no online. You couldn't see them. It was. The students couldn't watch them afterwards because we kept the videotapes under lock and key. They were very precious and expensive in those days. But anyway, that was. So this is outside in the garden. And I got the same, so there's, these are some of the undergrads that I know. There's Paul and co, David, Jill in the front row, Mike Rees was still there, Paul Garrett behind David, me. And There's Tim there, and Mari and Gwyl. Now this one I think is the one, so this is the one Judy showed. That is Paul Garrett, not Pete Anderson. It's Stephen, I was going to mention Stephen, because he has become very famous and he was here for quite a while. He was a great party animal, Stephen was. There's Rod and Paul. I'm here, there, next to, am I next to Hugo? No, I'm next to Sebastian. Dave's here. Dave came to us from physics with computer science, he'll talk all about that. Les is here with his moustache, Paul Lewis. I was hoping, we tried to contact Paul, but haven't seen him today. Now, I'm going to tell you a little story here. This was Jeff Little, who was in the University Air Squadron. And so a flyboy, if you like. And just a month ago, I got a WhatsApp message from one Sir Tim Berners-Lee. Now, as Nigel will know, this is not very, you usually have to track Tim down rather than him get in contact with you. And he just said to me, the pilot of this plane says you were his lecturer. This is from Tim, right, on WhatsApp. I said, what plane and what's his name? So then he sends me this photo. So this is Jeff Little, all grown up, BA captain, doing probably he's been out to do a selfie with Sir Tim. And he sent me a little handwritten note via Tim saying my lectures were the best. He's just being flattering. And giving me his email address. So I've just been in contact with him. Isn't that amazing? So that was just... Now here, Therese Coffee, eat your heart out, right? This is me smoking a cigar. That's the Count and Paul at one of our... Because in those days, as Judith said, you know, we were so small, we all went out to dinner. I mean, when the third years graduated, we all went out for a dinner with them. We knew everybody very well, and the postgrads, that was 2 of the 3 of them. Hugo was a real Count, I forget where from. So this is the small beginnings. It really was. Nobody did any research. David Barron didn't believe in writing grant proposals. He used to say, I get paid to do research. That's how I'll do my research. I'm never going to write a grant proposal. And he didn't.
Change the culture.
So, there was nobody to teach me how to write a grant proposal. So nobody else was doing it. I just had to do it and learn how to do it. And, work. People helped, but it wasn't like there was anybody you were following who could give you a guiding hand. Anyway, that was one of our celebratory dinners. Now this one, there's other photos. Dave, have you got any? This was the big do at Stoneham that Hugo organised, where we all dressed up very posh, and we had a posh dinner in Stoneham. And that's David and this other lady, I can't remember her name, who was maths faculty admin lady. It was a wonderful evening, as I recall. It was basically a garden party. We went indoors for dinner. We used to do all sorts of things like that then. Then we started to grow up and go to conferences, right? Write papers, okay, that got published in journals. This didn't happen before, okay? Nobody wrote papers as such. This is obviously Tim is the first. It's the European Conference on High Sex 1990. That's Andrew Fountain, who was the lead author on the first microcosm paper. I learnt I should never do that. It should have been me, the lead author, but anyway. That's Robert Caillou next to him, Tim's partner in crime at CERN. Ian Heath, who I think wore that leather jacket and possibly the T-shirt throughout his entire PhD. He was my PhD student. He wrote the first version of Microcosm, and Tim's obviously saying how big his links are, or his web is. He hadn't called it the World Wide Web here, but he put the first website up. That was December 1990. He put the first website up after that, and that Christmas, I think. And it was like we went international. We started, we just started developing a research culture, right? I forget, when did you come in? You weren't in the department then, were you, Tony? You hadn't. Which year did you join us? Yeah. So, the only way I could get hold of, and perhaps this will be true of the website page, the university web pages today, the only way I could get, the easiest way to get hold of, because we became the Multimedia Research Group in 1992. And Peter Henderson, who I haven't got a photo of, let me tell you this story. There were two, when I was in, Peter Henderson came to us in the expansion around that early 90s. Hmm? Thank you, thank you, Hugh, because you came sort of at that time, didn't you? Mm. We were expanding a lot then, and I haven't got many photos of that, but Peter actually did a lot of good things for the department, and he got us into groups. There was the text processing group, and the functional programming group, and I declared multimedia research group, which David supported. We were in existence from 92 to 2000. We became electronics and computer science in 1987, which was very important because electronics already had the research culture. They wrote papers, they had grant proposals. So although we all hated becoming engineers, I remember Dennis coming around to my house, I've told this story before, with a soldering iron, because he didn't think I was a real engineer, and he said, here, I'll use this. See what you can do with this. Huh? Huh? No, you came? I'm sure you came to our house in Wellow. I think so. Yeah. My brother's the same. He was an engineer, and he didn't think I should become one. Anyway, that was 1987. Did us a lot of good. Peter joined, and he said we should go and split into groups. And he also told me in public, perhaps I shouldn't say this as it's recorded. Anyway, we had one of the professors in the department, and it wasn't David Barron, told me in public that there was no future for me at Southampton, either at Southampton or in computer science, if I didn't stop doing this silly multimedia stuff and get back to writing programming language or compilers or operating systems, which I'd never done. But anyway, that was pretty devastating at the time. But David supported me, and then we started really, pioneering multimedia, hypermedia. Before it was ever, we couldn't return anything to the then ref. It was RAE then, wasn't it, in our group, because the journals and conferences just weren't acceptable as proper research. This was us. This is just pictures of us growing up. There's a group Christmas party now. That's David. He was always part of our group. It was Les. In the back there's Luke Moreau, I think. And that's me doing the state of the MMRG Christmas talk. Oh, no, don't require. That's in my front room in West Wellow with Dave and Nigel Payne. They had talent, I didn't. We got bigger. The Multimedia Research Group got bigger because we were doing things, writing papers, writing grant proposals, getting PhD students. Suddenly we were expanding really quite fast. John Dale and Stuart Goose. We used to have wonderful entertainment. I think there's a lovely picture coming up of... Oh, yes, there is a lovely picture, wasn't there? Everyone came to our parties because they were Christmas parties. That is... here's Amanda, who you will know still. Sean, is that Debbie? No. Oh, who is it then? It was in that... I can't remember her name. She was one of the original secretaries. Heather, it's Heather! It's not Sean's wife, sorry, because we were talking about it's Heather. That was Karen, my PA. I can't remember her name. Is that her name? That was Julie. Not my Jane. Oh, and Julie. Anyway, everyone came to our parties. That was the Hypermedia conference in Seattle, I think, with Hutch and Gary and yeah. Oh, where's the one? There's a lovely picture of Dave, which has disappeared. Perhaps it will turn up later. I was fiddling around with these last night. Never mind. It will, I hope. It doesn't matter about. They're just the party years. Now, look at the things. I'm not saying this to boast, but the point was that we were beginning to have an influence. I got an EPSRC Senior Fellowship in '96. I became a member of EPSRC Council. That was quick elevation in those days, in '97. I went to India with Tony Blair in '98. I got my... Oh, that doesn't fit. They don't really work there. I was trying to say the things I... Oh, yes, it does. 2000. Yes, it does. That's fine. Yeah, it was like what was happening. And every time when the leader of something gets elevated, the group gets elevated, right? That's the message I'm trying to get across here. You get recognition, both national and international. And the leaders of the other groups were doing the same thing. Tony in parallel computation, concurrent computation, Peter Henson in functional, David, of course, in the work he did, but he didn't buy grants and proposals, but he was so famous for what he did. You know, so everything was getting elevated. And I haven't brought up my... So then we get to the years when Nick and Nigel arrive. So we basically, I'd been running the multimedia research group, and we got money to expand again. And Nick approached us at a conference, said, "You got any jobs for agent-based computing people?" So we advertised a chair in, I can't remember, what did we call it, Nigel? AI or something? And you rang me up the day after the deadline. Is Nigel here? Yes, he's at the back. You rang me up the day after the deadline and said, "Can I apply?" Yes, you did. This again is from the Wayback Machine, the Internet Archive. When Nick and Nigel arrived around 2000, we became the International Intelligence and Multimedia Group, and we doubled or tripled in size very quickly. Here we are in the very early days. Dave, of course, was already with us. I assume you had your chair by then, Dave? 2000. Yeah. So it was real expansion years. We were attracting people who were either already famous or going to become very famous, both. We were a magnet for talent, and they were the glory years part 2, I suppose. The I Am years were stratospheric. Look how thin I was, God. Anyway, and they were also party years. Everybody there is very drunk. Nick has a way of drinking where he just keeps on drinking and gets quieter and quieter and quieter. Nigel's the opposite. Oh, here's the one. This is it, Dave. This is you. This is the famous Poke Me at Portchester slide. He used to live in Portchester, and he used to, after the Iron parties, fall asleep on the train. So he had a... Did you make it, or someone make it for you? Huh? Someone made it. So you could hang a sign around his neck for someone to wake him up at Portchester. This is just a collection of fun photos. That's Nigel, me, and Dave in San Francisco. What did we were doing out there? It was an early observatory thing. We were going out. Was it grid computing or something we were doing with? It was the one. But we were going out there to. Yeah, we were out there to persuade them to do something we wanted them to do. And then the one with Nick and Nigel is very drunk there, and that was at that was the web conference where Tim and you and me and Danny started planning websites. Not that dinner, but it was that conference, and that was in the Brazilian restaurant in New York. There's the famous karaoke photo with Phil Nelson and Nigel, and that one, I think that's Bashir, Nigel, me, and Leah Maxwell at Buckingham Palace. We just met the Queen. And basically, yeah, this is the group growing. Kirk always used to take photos from on high, and we grew and we grew. And can you pass me on there? I'm nearly finished. This is about when we got the I can't remember the exact years, but we applied for the Regis chair. Les and I, oh God, Joyce and I wrote the document, and we said we were really good at computer science. This is to Her Majesty, or to the servants. And we said we were very good at developing hypermedia systems, open access mandate. I mean, Les will talk about this with Stephen Hunter. We were the first department in the world to declare an open access mandate for papers. We talked about the new discipline of web science and open data technologies and agent-based computing, and this document won us the Regis. So then we with Tim and Danny, Nigel and I launched the Web Science Research Initiative with MIT. We were on the front page of MIT for a day. Not Southampton. Southampton didn't quite get its act together to put us on the front page, but you know. And this was, you know, the beginning. This is a whole other story. I'm not going to tell you the Web Science story now, particularly, but this was the first cohort, and we had Tim here, and that's Noshir, I realised in that photo. Noshir contractor, Kathy Pope behind him, and some of the that first cohort. Les is there at the back, me, of Web Science students, and that story then began. So this is like, so you know, this is me on the, signing the FRS book and getting my damehood from the Queen, and that's my mum there in her wheelchair. She was in a wheelchair by then, and so she got to get in the front row, and she was so proud, but also she felt so awful because she couldn't stand up in the presence of the Queen. But I said, the Queen won't mind. But the thing was, this was like, we were really riding very high then, and many of us were going off and getting these types of FRSs, FRNGs. And I just want to pay tribute here. This is to the pioneers, and I've got all the pictures of the 1990 Research Journal are outside, the people who were there, and there was Henry, of course, who, I wouldn't say supported computer science. He brought us into ECS to take us over, basically. Funnily enough, the next head of department was one David Barron, who was able to then funnel more money into computer science, and then you did take over from him, didn't you, Tony? Yeah. So it was really Tony that actually, he came down and did, Chris Gutteridge. Yeah, but we really started then to plot and plan expansion in computer science because we saw the way it was going. And now look, you know, we've gone from that tiny little group to being, I don't know how many undergrads do we have a year, 300 or something. And then Chris Harris, he wasn't in that research journal photo, he came over from aeronautics, but he took over from Tony, and quite surprisingly to us, he kept it going. And he was the person who actually appointed Nick and Nigel, I think. You just said. You were. So there's new people. I mean, there's people much later on who have, and I want to pay tribute to Paul for all that Paul has done to help bring life back into computer science in terms of investment from the university, rather than constantly just taking more students and expecting less staff to teach them. We are now on the up again, hugely, everything to play for. With so hopefully some of the new staff are here, but that. I just wanted to pay my tribute here. And I know personally, of all the mentors I've had and all the encouragement I've had, I actually owe it all to David Barron. Thank you, everybody. Not bad for time, actually. So, Professor David DeRoe, old friend. It's your turn to tell the stories and the part he played in helping to grow computer science to Southampton. We go back. What were you? You were an undergrad when I first.
Yeah. So.
I was his tutor.
Oh, yeah.
Yes. In '83, right? It's fantastic to be here. Thank you all so much. I had the benefit of seeing the list of presenters in advance of doing my presentation, so I chose a bit to talk about because I was here for 29 years. I can't do that in 20 minutes. So I'm also focusing on the glory years. And it's interesting having Judy and I sort of bookending this, like a pair of Lisp parentheses, because this is a different take on a similar period with a different programming language as my vehicle, which is Lisp instead of Pascal. Although I did teach Pascal precisely, and I didn't bring the book like Wendy did to show you because it's been falling to pieces for a very long time. It was very well used. So, formative moments, which could be ECS formative moments or my formative moments. Partial history, partial in the sense of not complete, and partial in the sense, as Wendy said, this is a personal story. I called this episode 1 as a way of inviting you to invite me back to talk about 2000s, but I thought there are other people here who cover 2000s very well. So, unlike Judy, I actually arrived already as a microcomputer programmer. So there's the PET, which has also been mentioned, Commodore PET 4K of memory, and an Apple IIe. My chosen career at this point was to go into medical physics, medical electronics. I chose Southampton over other universities because I could mix and match the physics and the maths and the computing. And I actually did as much computing as I could in the end. I knew there was a computer here when I came here in 1980 for my UCA interview. I saw that 2976 on level 2 of the maths tower. So here's the course booklet if anyone wants to look at it, from 1981 in maths. And you'll see from in the first year at the bottom there, Introduction to Computing, DWB in slot 7. And it has coursework and some lecture notes. There we are. So I arrived, first lecture in maths 4A, as was, is it still? First lecturer, David Barron, walks in. He wrote on the blackboard in the way he would. Time, yeah, like this. Time flies like an arrow. And I thought, well, so true, look at us today. And then fruit flies like a banana. And that was his introduction to languages. We've heard a bit about this, but I just wanted to show the evolution while I was an undergraduate and I was taking computer science, computer studies courses. David Will Edmonds taught me in the first year. Gillian Lovegrove taught me machine language principles on the PDP Unix version 6. In the second year, I was in University of Road doing this in the lab, as you can see on the right here, user guide to the computer studies laboratory by R.E. Austin, as has been mentioned. You can see an evolution that occurred then from computer studies group to computer studies department. And this is around 83. And some people might remember CSG Ed. Let me know if anyone does. I, as a third year student, very formative moments these, I did a third year project on maths and music with Keith Lloyd, who some of you will know, who also knew Lisp, which we're coming on to. And my personal supervisor at that point was Ray Dinverno. And what these two people had in common is they had offices at the top of the maths tower. And this was my image of what academics did. You sat in an upper ivory or concrete tower in a room doing scholarly things surrounded by academic journals. That was Keith Lloyd with a beard. That's what inspired me to become an academic. It turned out it isn't like that at all. Right? Although going to Oxford made it a little bit more like that. Ray Dinverno taught a new course on Lisp and AI using that book in my third year. I went on the year after to support him teaching that on the Honeywell mainframe, which was then on level 2 of maths. And I supported that for some years. So this is how I got into Lisp. I haven't got time to tell you why Ray was using Lisp, but it was due to general relativity and the Bondi metric, whole other story. And David Barron, in my third year, taught me intelligent knowledge-based systems, which is how David got to know me, I got to know David. And I wanted to put this up because of that. These are my lecture notes. I've been through the archive. The archive looks suspiciously like some blue crates. Sorry about that. Much of AI is about problem solving. And it talks about Winston, from Patrick Winston, treats various problem solving paradigms. AI has changed a bit, hasn't it? But this is the AI I was doing back at that point. This is what I was taught. I'm still doing some of this now. I was writing some code doing this kind of AI yesterday, as well as the stuff we do at the Turing. So I got a PhD position. I was, SERC studentship with Rod, Paul, Hugo. Which house was it in University Road?
131 to 125.
I think we were in 125. Ken Thomas was up above. That's why I'm pointing up. This is just, that's 131. I ascend to 131 in a minute. So David Barron, at the beginning of my PhD, 84, gave me this little exercise. It's to install Lisp-Kit Lisp, which was created at Oxford, and the authors include one Peter Henderson. So I set about doing that, and about that time, Mabelson and Sussman came over from MIT launching this book, and David also gave me that, and I taught that from then onwards, for a very, very long time, and then handed over to Luke Moreau to do that. Partly a successful course, not because it had a really important role in the curriculum, because other things were changing around it, but it's a really good book and a really good course. what actually happened is I had a lot of trouble transferring the Lisp Pascal's source code for the SECD machine from the Programming Research Group at Oxford. And I had to work out how to do the file transfers using the current, at the time, campus packet switches change and early Janet and all of that. And thus I learned about systems. And 1 year into my PhD, I became the department's first Unix systems programmer. Seemed fine, didn't have many computers at that time. Maybe 3 and only 2 of them worked. I did that year, and then a year later, Les joined me, and then after that, Tim Chow joined us. So we were the original systems programmers. This is the network. At that time, you can see our relationship between the Department of Computer Studies and the Clearway network and the computing service. And I've got so many memos and diagrams I could show you about that. You can see Les followed me because there's a backup tape of my home directory by Les on a machine called Vicky. And I also solved the file transfer problem around the planet. As Judy mentioned, I went to MIT in '88 and physically carried back this tape, which is the 6001 course and problem sets. So, and I took these photos this weekend in my office. I still have those tapes. Here's a memo from David in '86 around the time of, not the merger of computer science and electronics, but we have to, the politically correct phrase was the two departments coming together to form a new department. That was the language. This is interesting because he is saying, do we have enough electronics in the new computer science degree as it was being formulated then? How come I can hear music? Is that just me? What did I say? There was a hyperlink on this. No. So I was thinking links. But I come into this with an electronics background. I was very enthusiastic about this merger, and there's a kind of an advanced guard of people who got to know each other. So from electronics, it was Adrian Pickering and Ed Zaliska and others of the Trice Network. Adrian had written an editor. What was your editor called? SE? Yep. And I was the electronicsy guy in computer science. And so, yeah, and it was a while till we had a computer engineering degree that put everything together. One of the reasons I think we retained that sort of independence within the larger department and didn't just get absorbed and forgotten was that we had a separate degree, separate timetable, all sorts of stuff made us separate. Wendy mentioned Sebastian. I need to mention him at this point. David appointed me in the sense that I've got the PhD place and then systems programmer. Appointed Wendy. 84, Wendy started the lectureship, I started my PhD. Appointed Sebastian. And yes, that is Les's moustache on the left. Sebastian is known in Southampton, as Wendy mentioned, for LaTeX. And if you're running LaTeX on a Mac, you probably still have his code there. In Oxford, he was known for something else, the Text Encoding Initiative, TEI. It wasn't until his memorial in 2016 that we had both things together. So the morning covered his Southampton life, and the afternoon covered his Oxford life. And everyone, apparently for the first time, realised that he'd sort of changed the world twice in a very, very humble way. It's really quite an extraordinary impact story, as they say these days. I completely agree, Wendy, he should be with us now. Yeah, that I don't know, you can date that photo, I'm not quite sure when that was, Les can probably tell us. These photos actually are up on the little display outside, I noticed. I think these might be 88, 89, and that's 90. I like that display, it's a kind of amnesty for people with ECS artifacts, so I might donate a couple of things. Here's a poem, Wendy, about me not going swimming.
Do you want me to read it out?
Yeah, I can read it if you like in a minute. These other pictures you've seen, what I want to point out, the green stars here, these are people who lectured me as an undergraduate. Okay, David Barron, Tony Hay, Ken Thomas, Gillian Lovegrove. Actually, not in this little bit of my archive. Archives are always a matter of sort of preservation, an accident of preservation and discovery. I don't have Will here, and he also taught me. So as mentioned, around this time then, early 90s, Peter Henderson had arrived. He also became one of my PhD supervisors. Hugh Glaser arrived. We had these 3 labs, the text lab, the Lisp lab, and the multimedia lab. They became research groups. That's the Lisp lab logo. Programming language enthusiasts in the audience will recognize that's a play on the notion of reflection. But the computational systems lecture notes, this is the 6001 from MIT. This, I think, was the first course we had with the lecture notes on the web. In 1992, I went on sabbatical to INRIA and worked on distributed Lisp while Tony was waiting for the T9000. And when I came back, I put the lecture notes up on the web. I came back with a web browser, or as my French colleague always called it, a web bruiser. So I came back with a web bruiser, and we taught CM203 on the web. I don't think just putting the notes on the web is the same as teaching on the web, but that was the first. And just to note our dedication to teaching, as Wendy had also mentioned, there's a couple of CSTRs there with Hugh Glaser about what we were doing with teaching applicative languages, teaching parallel and symbolic computing. I still stand by that dedication to teaching. I'm proud still to be teaching similar things today. But then, we're just in the early 90s. This picks up on Wendy's story. I came back, I was in the Lisp lab, went to INRIA, came back into the multimedia research group where there was the web, or where there wasn't the web. I used to go along at coffee breaks, and then the rule was you couldn't talk shop. So I never got to talk about it very much, but eventually we managed to talk about the web. Les and I did the distributed link service and so on. And here is a video, just a few seconds I want to show you, of the day Tim Berners-Lee gave a talk about how he invented the web in Zeppler ES2 by the look of it. Exactly.
Well, the brief that I gave was I really wanted to talk on how I invented the World Wide Web. But I invested that as origins and perspectives of the World Wide Web. Let me explain my perspective on Tim's achievements. Is I used to be a physicist, and my heroes used to be people like Dirac and Feynman and Schrödinger. But since I've become sort of rebadged as a computer scientist, my heroes have become different people, people like Turing, but also people who changed the world, like people who invented the spreadsheet, video games, and also, of course, people like Tim. And the nice thing about people like Tim and the others is that instead of being mega brains like Feynman and Schrödinger, they're only just sort of enormous brains.
You guys.
Is that I work with his bosses at CERN, who have a very tenuous claim to fame, is that they were the people who didn't prevent Tim from netting. It wasn't anything to do with CERN's grief or mission, but the physics community, I think, deserves some credit because they were the people who spread it, and Tim did. So I hope you'll say it.
So I'm going to stop it there. I've got multiple videos which you can watch later in a bar somewhere. But yeah. So I think on the blackboard behind that video was, I think, Ted Nelson's notes from the week before. Yeah. Right? That's the great irony of that little video clip. Here we are. So I'm only just going to touch on this bit of 90s, and then I'm going to make some useful comments about ECS. Hypertext 97 was an extraordinary event, very ECS. With the amount of tech we needed to do an international video link through to Slack in California using ISDN to link up keynotes to Ted Nelson. The huge amount of work done by people, some of whom are in this room, in putting on that production of hypertext in Alderwood. And just 2 or 3 weeks ago, I was in the Computer History Museum in San Francisco. Actually, down the 101 in the old Silicon Graphics place. The mug for Silicon Graphics was on an earlier slide. And then we have Microcosm as an exhibit, donated, I think, by Wendy, in the Computer History Museum. As we said, the rest is history. I do have, and I'm not going to play it all, the 8-minute video we made about the Hypertext 97 thing. I'm happy to play this later. I'm just going to play the first few seconds.
Play the first bit, then play it through the refreshments.
Okay, we can do that, yeah. And the verse seems to be consistent with Wendy's talk just now. yes, there's famous bits in it, the dolly shop, for example. Stephen Adams has been mentioned by Judy. I went in 97 as well as doing these things like hypertext on sabbatical to MIT to work with Abelson and Sussman of that book fame, and with Stephen Adams on amorphous computing. This screenshot on the right there I took yesterday. My code is still available on the MIT website for when I taught amorphous computing. I came back and taught it here as distributed systems. You see the pattern, for many years, and then handed it over to very capable colleagues who looked after that. Thank you very much. This particular edition of the exam paper I'd love to show you has the famous smart beer map exam question, which we wouldn't get away with through any examiners today because you can't assume students know what alcohol is or around. But it was a great exam question. So reflecting on all of that, the seeds were sown. I don't need to tell you anything else because it all comes from what you've seen. And I try to write down some of the things that I think makes ECS. And as Tim Norman mentioned, interdisciplinarity, the whole research culture and research environment, the applied approach, teaching is important. It's very much about the people. It's one of his very strong things. It's also about comms. Thank you, Joyce. I learned that here. It's a lot about having fun, as you see, and in a sense, it's a can-do environment. Anything is possible. And I just took all these things as granted because this is all I knew. And then I've been to other universities, and you can't take these things for granted. It's special. Having it all together is special, and that can-do attitude is incredibly important. So anything is possible. I'm not going to talk about 2000s. We launched the EnvySense Centre. I want to mention that because it's an interdisciplinary centre I created. And one way of describing my career is a series of interdisciplinary centres. There's my inaugural lecture. I'm not going to talk about e-science. I've chosen one picture because, actually, interestingly, there's Nosh, who's come up previously, Nosh, a contractor, and there's Geoffrey Fox, who came up in Tony's talk. But the main reason for including this was that head of the scientists is Jeremy Frey from chemistry. And I wanted to mention Jeremy, who was a very important collaborator throughout that period. So that's it. This is where we started. You've seen this picture before. That's the back of 135 University Road near the Porter Cabin. See the Porter Cabin on the left there. And this is me today. This is what I'll be doing as we start a new academic year in Oxford. Look how much of this is ECS. There's me wearing my Software Sustainability Institute t-shirt at the annual Digital Humanities Conference, second biggest on the planet, summer school, which I'm now responsible for in Oxford. So this was taken in July. So two of the things I've done, both interdisciplinary centres. Petra, some of you are aware of, big Internet of Things, National Centre of Excellence, which is that pervasive computing, EnvySense, that aspect of my electronics life from ECS coming through. And a centre at the Royal Northern College of Music, Practice, Research and Science and Music, PRISM, with Marcus de Soto from Oxford and some excellent composition colleagues and students from RNCM. And I do that work in collaboration with Alan Turing Institute. So that third year project on maths and music, I've realised today as well. And I went to Oxford in 2010 to become the director of the Research Centre, and see if you recognise this story. In 2017, we merged with the Department of Engineering Science. I'm not going to try and rebrand the Department of Engineering Science, but it was a very successful merger, and those of us who were the OERC team are very much an integral part of the Department of Engineering Science today. Maybe I got that idea from ECS. Thank you very much.
Oh, thanks, Dave. Well, I suggest we do. Go grab tea, biscuits, and then why don't we put the full video on as you come back in, so if you want to see the full video, 5697. And speakers, come down the front. We will do some
Hi, Sim. Can you hear this mic? Can you see? Can you hear me at all, Sue? I'm not seeing that come back into that Teams call. Wow. on the vMix machine? Yeah, it's that full, it's maxed. Yeah, nothing. Do I need to select it from on? Do I need to select anything from the webcam thing on the Mac? Or do I? Oh, what am I saying? Okay, hold on. What am I saying now? Okay. Yes. Okay. Right. I've got the audio now. It just needed to. I needed to set it to be the input on that now. So he's seeing himself back. So, which is, yeah, but that's because he's that's because he's on the vMix call, isn't he? So he won't see. I want to send that now. Yes, he sees slides, but it's mirrored, so I want to not mirror that. Okay, so I think that's sending out to him. I think so. Two. Yeah, that's what I'm trying to do for that one. They've just got slides they want to put in and out and stuff, that's the only thing, so I've got to mix the slide machine into this and this as well. Yeah, I've got touch on it, Alright. Okay, I think so. Yeah, I just need to check that the audio's coming through, that's the only thing now, so. Alright. Cool. Cheers, man. Bye. Just bye. Bye. Hi, Stephen. Can you hear me? Can I just get a test back from you then, just for 2 seconds? If you
Could you make it a little bit?
No problem. How's that for you?
How about my volume?
Yeah, you're coming in loud and clear.
I'm getting secondary feedback here, though, a little bit later than when I say it.
Yeah, there might be an element of that due to some of the mics we've got in the room. Just so you'll be able to, they can talk to you, so you'll be able to hear back and forth.
I did there, but I'm not hearing it now. Yes, now I just got a feedback flash after I started talking to.
Is that any better now?
It's the only time I know it's happening is when I speak. Right now, as I'm speaking, it's fine, but it came in a flash a minute ago. Also, how's the timing doing out there? How much off are we?
We're on schedule, I think. We're not too bad. I've got Les here as well. I'm just.
Hello, Stephen. Can you hear me? Stephen.
Yes, I can.
Oh, good. Yeah. So they finished. Well, I don't know, 10 minutes late, something like that. But they're going to come back in at the normal time at 20 past.
Are you alone?
Oh, hello. I can. Oh,
Alone there, Les?
sorry.
Are you alone there in the hall?
Oh, there are a few people making their way back in now, so I expect it will start to fill up.
Okay, can we chat for a second?
Yeah. People are saying hello. You can't see who they are because you've got a rear view of them. I expect. Have you?
Yes, a rear view. No, I do. I see them also coming in. But I have an important question about timing.
Have you?
Yes.
Did you manage to get your 20 minutes prepared?
Yes. That was what I want to discuss.
So to say hello to Stephen, we have to face that way and say, hello, Stephen.
Dave DeRaw is saying hello.
Hi, Stephen.
Oh.
Hi, Dave.
Do we know what the lag is, the delay? Is that his fault?
Les, can you hear me?
Yes, I can hear you.
All right, so I wanted to ask you to, if possible, just plan the introductions so I can get through this without while breathing.
Say that again.
Forget the introductions. Let me read it in a leisurely way so that I can get through it in time.
Okay, I will keep things as brief as possible at the start. Chris Gutteridge is here. Oh yes, up there. And Jessie Hay at the front. So we have to have that slide with Jessie's picture on it. Oh right, okay. And we don't know who it is. Eric. Oh, Eric? Is this your phone?
Is there a camera here?
I'm not sure what. I think the view he's got is from the camera up there.
Hugh Glasser.
This is Hugh Glasser.
Hi, Stephen.
Thank you. I really see you.
See you later.
Here you go, just taking him off, I think.
Oh. We're a bit depleted, but it's all being recorded. I wanted to read Dave's poem. Are you ready? So it starts to Wendy, Rod Crawford and Paul Farrow. Subject swimming. In anticipation of a retrospective apology. We used to go swimming every Thursday lunchtime to Fleming Park. Didn't we, Dave? Well, you came eventually, you did. Leonora, she was the swimmer. Sebastian got married. Anyway, still not yet wet. What left TB7, I asked myself, and a way to reply. No, what's it? What'll it be? B. Oh no.
Question mark?
What'll it be? I asked myself, and a way to reply. Well, I'm jolly busy. I really have no trunks. My memory is dreadful. I haven't swum in months and can't remember how. Not convincing? All there in swimwear, Wendy, Rod and Paul, but David's never there in Eastleigh swimming pool. Today's excuse. Sorry, I can't make it. The Honeywell, you know. Any decent hardware would have let me go, but not the Honeywell. Chorus, hardware and software, brackets and C. None of these go swimming, just like me. And so I remain, still not yet wet. Well done, Dave. Eric.
Could I add something?
Yes.
Memory is a very quirky thing.
Yes.
I remember Stephen Adams saying to me, Dave DeRaw says he can't swim. But when I saw him, he got in the water and did this.
By the peak time of swimming, there were 3 cars used to go. Do you remember? Anyway. Right, so that's when we have time to have lunch breaks. Is Stephen around?
I believe.
Oh, Stephen, are you on? Yes. Stephen, it's wonderful to see you. Let me just introduce you a little bit, in the sense that you've got Tony Hay. Can you see us? You've got Tony Hay sitting in the front row. And I remember when Tony... Can you see him?
Yes, the back of his head.
No? Yeah. So, oh, I see. So, I remember when Tony came to my office and said...
The sound keeps fading in and out.
Can you hear me?
Aye.
He's frozen.
No, I can't.
Well, there's a bit of a gap here. Are you right? Can you hear me?
Yes, yes, I can.
So basically, I remember when Tony Hay came into my office and said, shall we take a risk on employing this psychologist? And it was the best decision we ever made. Love you to bits, Stephen. You're going to talk about open access with Les. Wonderful to see you. And Les Carr, who I rescued
From Plessy.
to come
Plessy
back.
Research and Technology, also known as Pratt, but unnoticed by the people who called it such. Yes, so I'm now a professor here, Professor of Web Science, but I remember when I was just a junior underling of Dave DeRoy, and Tony Hay came to me with one of his irresistible offers to improve my life, which was to help Stephen Harnad, who was a psychology professor at the time, who had some amazing ideas and that we were very interested in. And this was just before he came over to seek solace and in ECS itself. Anyway, my role here is to just pass on the baton to Stephen Harnad, who will talk about open access and the work that we've done here and how it fits in with his life's passion about research. And I will occasionally suggest that there may be some slides that are relevant to what he's saying and try and get them shown at the same time. So, Stephen, it is over to you, and I hope the internet holds out. Stephen, your go.
Yes, the trouble is that it's fading in and out. When the screen turns purple, I hear you. Can you still hear me when the screen is not purple?
I can hear you. Please start your talk.
It's called skywriting. It's good to be back at ECS, even only virtually. I want to start by thanking 3 people without whom my career would have ended in 1997 when I resigned from my professorship in psychology at Southampton. Tony Hay took me in, Wendy Hall supported my work, and Les Carr, a genuine computer scientist, covered up my heartfelt thanks to all of you. Is this working, Les, or is this fading out?
Just keep going.
Okay. Now, for a selective overview of ECS's role in the open access movement from 1997 to today. Les, I'm counting on you to show the timeline.
Can we have the first slide up, please?
Yeah.
Yeah, that's it, thank you. That's the only one I need. It actually starts a bit earlier than that, about 300,000 years ago, at the beginning of the Anthropocene era with the advent of our species. It was actually even earlier than that, with the advent of unsupervised and supervised or reinforcement learning in our invertebrate ancestors. I'll fast forward to between 50 and 100,000 years ago with the advent of language. Language was the first and most important of 4 cognitive revolutions. It was language that made culture, scholarship, and science possible, to then be passed on by word of mouth until the second cognitive revolution, which was writing. Language had been a neurobiological revolution. It changed the speed of thought itself. Writing slowed it down because not only is writing slower, but its turnaround time can be glacially slow, hours to days and weeks to even months and years, till you get an answer completely unaffected, which have co-evolved with the speed of speech and the speed of spoken interactions. The brain is best adapted to real-time conversation. Letter writing is not, but it has the virtue of leaving a permanent record. That record, though, was only there in one place, or a few if they were hand-copied. It was the third cognitive revolution, the Gutenberg revolution of print, that broadened the scope of written communication far beyond just a few interlocutors. And it speeded it up a little bit. Writing and print are largely one-way streets, but science isn't. Even after the invention of print, scientific exchange is still taking place in the form of one-on-one letters. So, to widen access to scientific findings and to preserve them, but the timing still weren't right. On the other hand, real-time symposia and conferences did permit real-time exchanges, drawing on thinking that was closer to the speed and potential of thought. But, let's admit it, conferences are still mostly one-on-many, and no one has yet found an optimal or even a satisfactory solution to the organization of many-on-one conversation. Perhaps there isn't one. Not even the fourth cognitive revolution, the post-Gutenberg and to access and to join. But this talk is not about social media. The kind of skywriting of interest here and skywriting. Let's make inventory of its components. It's still about written communication, not about a massive live oral Zoom academy like this, even with the spontaneous speech-to-print transcription, although that has a lot of interest in education. The written scholarly corpus consists of scientific and scholarly journal and conference articles. I'll focus on journal articles because they have a constraint on them that prevents them from becoming open access blogs, though that constraint is not always, perhaps not even often, all it is made out to be. It's called peer review, and it means qualified experts reviewing and evaluating the work Of course, not all publications just publish or perish, but publish work of quality. But what is the metric of quality? This has been, with few questions asked, entrusted primarily to the expertise and conscientiousness of peer review. But the scope of the distribution of expertise and conscientiousness in peer review is like every other biological trait, Gaussian. So what is the metric of quality in that bell curve? A somewhat tautological metric, resembling the PageRank algorithm that Google later went on to put to another purpose, citation. and individual authors can be ranked the same way, by citations. This has given rise to the discipline of bibliometrics or scientometrics, of which I became briefly enamored. But that's another story. The bottom line was peer review is needed to do quality assurance on research articles, and the measure of that quality was some form of citation metric, a measure of the uptake, the impact of your work. Now let's take a step back. How publishers get involved in peer-reviewed research publication? Originally, it was for Gutenberg reasons. Printing made it possible to distribute research much more widely than one-on-one manuscript writing, but it was not free. Someone had to pay for the printing and distribution, not to mention, presumably, the peer review, the guarantor of quality. That journal publication was their clientele. Who? Well, surprisingly, it was the authors of those learned journal articles, not for access to their own articles, but for access to the articles of their peers within their research specialty. And there was a period when learned journals were sold as individual subscriptions to individual authors' users. And those clients were also the same authors who were reviewing the work of their peers to assure its quality. The surprise was that those same author-scholars who provided the content, and those same authors wearing their referee hats to peer review one another's content, dutifully provided both their products and their services to the publishers gratis for free. The era of individual subscription subsided, and it became author-scholars institutions who paid to subscribe to their learned journals. The insult of having to pay for access to it was removed from the injury of providing it and our refereeing services to our publishers for free. One can speculate about what kept the scholarly community as well as their funders, their universities and research councils in this state of bondage to their publishers. The prima facie candidate explanation, the need to pay the true costs of publication, can be dismissed as being not only false, but nonsense in the post-Gutenberg era of online publication. But there's an enormous layer of superstition in academia, traceable to the ethos or the edict of publish or perish. Scholars have to conduct our research also provides the content our other calling, which is to teach it to the next generation of scholars. So we dutifully do our research, write it up, and submit it for publication. Publishers agree to take it into consideration if it meets their quality standards, for which they whistle for their peer reviewers, us, to go do our unpaid duty. Referees, too, work under the publisher-parish edict. We may choose anonymously to refuse to recommend publication for immediately upon its publication. Then at last,
Thank you, Stephen. Could we have the slide deck up? Thank you, Stephen. I'll just whiz through some of these things in a minute or two in closing. So this was the first decade or more of the activity that we had. Stephen talked about his subversive proposal of using the internet to communicate research. We created ePrints as a way of delivering some of those ideas in the year 2000. And we turned it in, we had an enterprise mechanism launched, ePrint Services, which was actually allowed institutions to pay for us to do that, to provide the software for them. If we, can we just go on, so that was the time in 1999, Stephen would talked about that, of when we had the idea for ePrints. Next slide. That's Rob Tansley, who created the open source version, the first open source version of ePrints, and then was poached by the Americans to go and write the DSpace, which was turned out to be a competitor for us. And then in the next slide, here's the early ePrints team with Jesse Hay, who was our University of Southampton library mole supporter, working for open access and ePrints repositories. And then the bigger team working with us, including Chris Guttridge, who took over Tim Miles' board, John Darlington, who's still our business manager. So this is still going on. It just turns out that a research idea that you embody in a protocol with a system, it turns out that it's very difficult to turn it into to change the way that a whole research industry does its job. And that kind of impact that involves parliamentary debate and argument with very expensive publisher company lawyers is not something that a department thought it was going to get itself into. But nevertheless, that was kicked off, I think, by Tony Hay, who not only employed Stephen Harnad, but provided our very first mandate for the use of open access in ECS, which went on to be hugely influential all across the world. But this is an ongoing story. The open access is not finished yet, and UKRI is still refining, and the publishing sector is still battling back. So we look forward to the next 20 years of this, and thank you very much for your attention.
The interesting thing, Jesse was asked by Stephen Hart to give a version of the subversive proposal in Bar. We looked at the slide and he was talking about Machiavellian combat.
Yeah.
I was amazed.
Stephen, did you?
Slides. We'd gone down to the beach. I was rehearsing my slides, and they stuck together. So when I got to Bath, I had to sort of peel them apart to give my talk.
Just
1996.
Sorry, Judy, you were talking earlier about your intemperate language. We heard some descriptions of academics being craven in Stephen's talk there. Anyway.
Well, Stephen was hated by the publishers, vilified, actually. Was never allowed on any committee talking about open access. But we kept it going. And I just want to clarify two things. Rob Tansley was my PhD student, and when he'd written up, I don't know how we found the money. Did Stephen find the money? Anyway, he wrote the first version of ePrints. And then when it was getting going, we launched it. Rob was poached by HP to write the first version of DSpace at MIT. When that was up and running, he was poached by Google to work on Google Scholar. And so I feel quite proud of the fact that one of our PhD students did all that. His sister still works for the EPSRC, Rob Townsley's sister, and I think he's still at Google. I think so. He had very long hair, didn't he? He was probably, anyway, married with N kids now and living in California, I don't know. But anyway, the other thing is there were 2 mandates, Les, just to make it clear for the record. You did the first one, Tony, on saying we will use ePrints and we will put all the records of our publications into ePrints. And I can remember electronics professors saying over our dead body. And the only way we made it happen, when I took over as head of department, was we paid postgraduate students to transfer people's publication records into ePrints. And then I did my first year as head of department, we passed the mandate that it had to be, if it didn't appear in ePrints, it would not be recognised by the head of department as a publication.
I can remember arguing that across the boardroom table.
Yes. Yes. They were very objective. Anyway, there you go. So we're going to write up this story, I think, at some point, because and there's so many myths about it all. And it is actually, Stephen was a bit negative at the end, but I mean, from my experience, you know, because particularly just last month, the US passed their mandate.
You need to look to the US example because it's the funding agencies who fund all the research have a mandate now to actually implement open access with no...
And the REF doing that made a big difference here, but the NSF doing it in the US last month.
Write down the history.
We should. Well, he's got the timeline there. We need to flesh that timeline out. Judith?
Can we pass a vote of thanks to Stephen, because that really was a brilliant talk.
Yes, it was. It was just... We will make it available with its full glory. We'll get him to record it without all the interruptions. Now, we have another video now. Are you ready to play Nick Jennings? Right, Nick is now, having left us to go to Oxford as their, whatever it was. Oh, God. You see, everyone was going to Oxford. Nick went to Imperial to be their VP research, and then bounced from there to be Vice Chancellor and President of Loughborough. And he has a council meeting this afternoon, so he couldn't come. But we have him on VT, as they say. Can you play VT? Nick was the first Regis Chair, by the way, just so you know.
Hi, good evening, everyone. My name's Nick Jennings, and I'm the Vice Chancellor and President of Loughborough University. However, most importantly, in the context of tonight's event, was the fact that I spent 15 years of my career at the University of Southampton in the Department of Electronics and Computer Science. I'm really disappointed that I can't be with you this evening for what seems like a fantastic event. It would have been great to catch up with so many colleagues and friends. Nevertheless, thank you for giving me the opportunity to send along a video contribution. I wanted to talk about some of the work that I did in partnership with colleagues whilst I was at the University of Southampton. Particularly tonight, I want to talk about human-AI partnerships. Many of you will know that AI is increasingly important for what we do as a society. It's really central to a number of our big societal challenges, be that in next generation healthcare, be that in smart grids, be that in agriculture and food provision, science, personal entertainment and information spaces, or protecting our critical national infrastructure. In all of these domains and many others besides, AI is an important part of our future, helping us make sense of a huge tsunami of information that's required to operate effectively these days in all of those areas, and as I said, many other areas besides. However, to date and throughout its history, most of AI has focused on single AI systems, so individual programs, individual AI programs, individual robots operating and doing their thing as if they are the only thing in the whole universe, a very solipsistic view of world life. So this leads to challenges around things like analyzing an image, planning a route from A to B, avoiding a collision with an obstacle. It assumes that most of the world is just under the control of a single agent, is the word I'm going to use in this context, and there's nothing else around in the environment that acts and does things. Even in the modern areas of AI that have really underpinned the huge interest that we now experience in the field, so in areas like machine learning and data science, still the pervading view is very much of a single agent system, a brain in a jar, if you like. However, as we all know, most real problems aren't like this. Most real problems involve multiple agents acting and interacting in an environment. So these agents, these actors, might represent different individuals, different groups, different organizations. But because they're in a common environment, they need to interact with one another to represent their distinct stakeholders, to represent distinct loci of control, or to represent distinct resources. All of these naturally give rise to the notion of a multiple agent system, a multi-agent system. Now, these interactions can take many different forms. The agents might be working together towards some common purpose, so they might be cooperating with one another. They might be coordinating with one another, so to making sure that the actions that they undertake don't interfere with one another, even though you might not be working towards the same overall objective. Or the interactions might be more selfish and competitive, in which case you're in the realms of negotiation. Now, most work in multi-agent systems, and in fact most work in my career, has assumed that the agents, the actors in these systems are programs or robots or UAVs. Specifically, we haven't particularly spent much time considering what it means to have a system in which there are some smart AI components, some smart AI agents, and some humans working together or competing against one another. So mixed hybrid systems in which there are people and software agents, and those are all part of the overall system as it exists. And so latterly, the work that I was involved with very much with colleagues at Southampton looked at systems in which these hybrids work together, people and software agents. And those are the examples I want to talk about tonight. So the systems, one of the main systems that we built in my time at Southampton was under the ORCID project, an EPSRC program grant with colleagues at Nottingham and Oxford and partners, a number of industrial partners, one of whom is the disaster response charity Rescue Global. We looked at a whole range of technologies for cooperation and coordination. It was a central aspect of what we did, and we wanted to build demonstrators in a variety of applications. The one I'm going to talk about tonight is in the broad area of disaster response, hence the work with Rescue Global. We're very interested in understanding what happens in the immediate aftermath of a disaster, so to understand what the situation is on the ground. And on the ground is a very confusing, evolving situation. There are multiple sensors giving multiple pieces of information, some of which may be consistent, some of which may be inconsistent. So in the human agent system that we constructed, what we had is we had a number of agents working together in order to fuse that information, in order to make sense of what was going on, to identify the hotspots of where there might be a lot of casualties. Then what we had was a series of first responders, human first responders, that would look over that situation and really try and interpret it and add their own analysis to it to try and work out what are highest priority sites in order to send the rescue teams and the rescue resources that we had at our disposal, such as UAVs and drones. And then in order to figure out that best way to go, the humans and the agents work together to co-create a rescue schedule, so to say, which groups should go to which areas in what order. And that could be generated, depending on the situation, firstly by a human first responder, and then sort of have the system critiqued and analysed by a computer system, or done the other way around. In either case, you've got the humans and the AI working together to co-create that schedule and to improve it and keep it going over time. This system we deployed with Rescue Global in the aftermath of the Nepal earthquake disaster in 2015 in order to help determine where water filter should be placed within the country. And our system that we developed, this human AI partnership, was able to identify and find areas that their standalone system, so without this close cooperation, wasn't able to find. So people on the ground who've been hit by this disaster were able to receive water filters that wouldn't necessarily have done so without this system. More broadly, the kinds of techniques that we looked at to underpin that cooperation and coordination methods, where we looked at how we could form scalable teams, so how we could figure out which groups of people and software agents and drones needed to come together to form a coalition. We needed to analyze and determine which agents should provide which resource at what time, and that was often based on models of trust and reputation. So those are some of the scientific areas that underpin the system that we were able to build and construct. Another relatedly important area is work that we undertook in the area of negotiation. So as soon as you have two or more agents that have their own self-interest and they need to come to some form of agreement or some form of resolution, then you're in the realms of some form of automated negotiation. Neither party can say to the other, you do this, and expect them to accept it. They might accept it, but it will be as a consequence of some negotiation process. So during the project and during my time at Southampton, we looked at a whole variety of methods and techniques for doing that negotiation. It seems like quite a simple, intuitive human process. When you try to construct it and build it into automated programs, or even more harder, into humans and agents interacting with one another, it's a very complex area. So we looked at techniques often based on game theory or mechanism design to try and understand the sorts of outcome that might emerge from these interactions, to see whether the system and the rules of the game that you put in place in order to achieve something led to desirable outcomes. In more technical terms, in terms of the sorts of equilibria that you were able to predict. So what could you determine, what could you say about the likely outcomes that were going to result from the interactions that happened within the system. We also looked at other shapes and forms of automated negotiation, so bilateral encounters, we looked at auctions, and we also looked at negotiation systems in which not only were you exchanging proposals or offers and counter offers, but also you added some arguments to go with those. So accept this particular proposal because it's going to be the last offer that I'm going to give you, and I really can't give you a better reduction. So very much more human in style type negotiation. So automated negotiation was also a central aspect that I undertook during my time at Southampton, with many PhD students and postdocs as part of a big team while I was there. So this notion, which, as I say, I came to somewhat latterly, very much influenced by colleagues who were in the department, about moving away from just considering computer systems and systems in which multiple agents interacted with one another, led me and the team to the notion of humans AI partnerships. And partnership is an important word here. It's meant to signify that the humans and the AI systems are working together to achieve their particular ends, what they're trying to get to. And in these sorts of systems, what you want to have is that the agents and the humans interact with one another in a very rich and flexible way. And if you can achieve that not only makes the robots, the machines better, but it also leads to a rise in the humans as well. So the idea is that you can make, through effective design of those interactions, both the humans more efficient in terms of what they do and more performative, and also their augmentation to their computers also more effective. In these kind of systems, neither the humans nor the agents are always in charge. That dynamic and that control relationship changes over time depending upon the situation. What you want to achieve is the partnership plays to the strengths of both. So humans are good at some things, computers are good at other things. Let's make sure that the humans focus on what they're good at, machines focus on what they're good at, and then together you get that increase in performance. You also, in these kind of systems, you need to continually establish and sustain cooperation. So it's not always a fixed system with a fixed number of agents in fixed roles. There's a degree of dynamism. Some new agents come in, some agents go, some roles change, some roles don't change. You want to keep your dynamics of your multi-agent system very much in line with what's going on. And the key part, and one of the key bits of challenge, I think, for the whole area is really getting the machines to be better partners of humans. We spend a lot of our time as computer scientists constructing systems where the humans have to adapt to what the computer system does and wants. And that can't be the way forward. What we need in these sorts of partnerships is we need the machines to be much better partners than they currently are. So we need to be able to construct flexible interactions that support suggestions, queries, and explanations. And I think that will be very much forefront of the next generation of many areas of computer science that will need to come together with other disciplines that look at interactions in order to figure that out. So that's what I wanted to talk about. Hopefully this reminds you of some of the work that I did at Southampton. It will be very reminiscent for some colleagues who were integral in this. I'm really sorry I can't be with you tonight, but I hope you have a fantastic evening nevertheless. Thank you very much.
So we have a fantastic evening, nevertheless, that he's not here. Right, are you ready, Sir Nigel? Yeah, they were great fun those days. We had some amazing time and some amazing research and impact on teaching came out of those 10 years we were I Am and a few years longer. And although we've all gone our separate ways, we still meet up. We still, Nigel and I used to travel the world together for a while. Almost every month we'd be going somewhere, spreading the gospel of web science. But they were very, foundational years. And I think our impact has been felt both separately and collectively since that time, which of course was at Southampton. So, I don't know what pictures he's got to show us, but it's your turn, Nigel. The spires of Oxford.
The dreaming spires.
Welcome back.
Yes, indeed. Well, it's great to be back. It really is great. I mean, echoing everything everybody has said, this was a really consequential period of time, and I'll talk a little bit about that. Yeah, this is my kind of current gaff, although, of course, I've also got a strong part of my life is in the Open Data Institute in London, which I'll also talk about. But it all kind of started, well, a long time ago. I mean, the University of Edinburgh was my kind of original alma mater. You know, it was a Department of Artificial Intelligence that pretty well was the only one in Europe at the time in 1978. That was me starting out with some of my cohort of PhD students. Rum old crowd there in the top left. There was only one textbook on AI, kind of one set of undergraduate notes that they'd stapled together. We were all taught Pop 11 at the time. Many of us kind of rebelled and found ourselves in the halcyon fields of Prolog, which was a much cleaner experience. And from there to Nottingham, and a time when AI was enjoying one of its periodic renaissance. That was in the period of the ALVI conferences, the ALVI initiative, in fact. And in fact, this is a picture of me at an expert systems conference, BCS Specialist Group on Expert Systems. Stuart Morley here. God, apparently they're really bad. That's me. That's Stuart Morley, Unilever. And there was a lot of industrial interest at the time in knowledge-based systems. The magic then was to build rule-based systems or constraint-based programming systems. Or frame-based systems. In fact, we took that a long way. This was a system that, with my first spin-out, was a system that could convert 2D layout into 3D spatial layout for chemical processing. Still, elements of which are still in use by a company called Aspen Tech in the US. So I was kind of in that space, and none of us had really heard. Well, none of us had heard of the web. At Nottingham, two of my students were just becoming infected with the web, and again, because we're in the department of psychology, Stephen's ideas were making their way into psychology. So the idea of the web as a universal information space was attractive, but those of us in the AI group really weren't getting it, except into those areas where we were interested in the notion of knowledge representation, so the use of ontologies, and these kinds of ideas that started to emerge in the semantic web caught our attention. Two of my DPhil students, Louise Crowe and Jenny Tennyson, were working on projects that looked to exploit the web and data on the web at scale in the late 90s. So that was interesting. On arriving here, fresh-faced, along with Nick, it was, I think, one of the things that really appealed to me, having spent actually 16 years in Nottingham in the Department of Psychology, setting up an AI group there wasn't enough engineering chops around to build the systems at scale that needed to be built. There were some great insights around, in fact, they often say that psychology is a field that's in possession of all of the interesting questions, but with no really interesting ways of answering those questions, and which was kind of a stupid thing to say in many ways, but it kind of, at the time, what I did notice was, despite our efforts to, we introduced degrees in AI and cognitive science at Nottingham. We had PSC, BScs in cognitive science and AI. It was always hard yards to get those interdisciplinary boundaries crossed. It was something I was always keen to promote, and what was interesting about my interview, my early arriving here in 2000, was a sense that within an engineering, electronic and computer science department, surrounded by engineering skills, surrounded by aeronautics, surrounded by a whole range, and a psychology department that had outreach as well, chemistry, there was a genuine sense of interdisciplinary outreach. It was really quite striking. But there was also access to way more PhD students, postdocs, and undergraduates who had strong underlying programming skills. And that was important for the project that we went on to carry out. Come on to that. Anyway, a bunch of other stuff happened here that I could never have anticipated. I want to say something about that story. Many of you will have lived some of that experience. We did it together, and I should never forget that. My one experience, of course, my first inaugural here was this. It was a talk called Artificial Intelligence, Brute Force and Insight, which prepared for extensively. Yorick Wilkes introduced it. We're in a nice big shiny lecture theatre, and the archiving didn't work. As far as I know, there is no record of it. It was lost or overwritten or not properly taken down, which is actually, I've got the slides for it. It's kind of a shame in a way, because I really would have it would have been a good kind of test of some of the views about what the art of the possible was, but also where I was profoundly wrong about some of the kind of things that I've been saying. I think that's always the interesting thing about looking back on anything you say, is how things interject. The next one, which was my exaugural, just 15 years later, I think was recorded and is available. I hope, but who knows? Who knows?
Southampton's just taking all the archives down.
Reflecting on that, and of course that brings us to a very interesting question, which is one that Vint Cerf talks about a lot, which is the digital dark age, that we are in danger of losing through a whole variety of circumstances. Huge amounts of our collective memory, even though we have it, as you might think, distributed, it's all somewhere on somebody's memory stick in some format or other, but actually it's a real effort of curation and consolidation, and it's great to see that as something that the department's taking seriously here in events like this. That early history, that deep history of the origination of the department here, I'd heard bits of that, but I heard nothing like that complete kind of a presentation from Judy and Tony and others, so it's been great to hear that. I arrived here with the intent to put together an IRC, an interdisciplinary research collaboration. This had been kind of partly forged just in the end of my tenure at Nottingham, and then with the appointment here, we brought together the intent to bring these universities together to engage in what we call the ACT project, the Advanced Knowledge Technologies. And again, you know, it's been because of many colleagues here that we were able to make what I think was extraordinary progress on a number of key problems, which again, in retrospect, all look kind of inevitable or quite prescient. Some of them, none of them scaled in quite the way we might have expected, but somebody made them scale, not necessarily us. Interesting where you might look at that. There was this whole notion of a knowledge life cycle, always trying to present the thing perhaps in a too much of a cleanly and systematic methodology. The fact about the real world is it's messy, and people don't ascribe to complete joined up life cycles of anything very often. What's interesting about this, the bits of it thrived and went on. We built one of the world's first graph-based 3-store engines. Steve Harris and others built, in fact, a quad store, a 4-store that went on to generalize this idea. Essentially a large database for graphical representations in RDF of the world. Okay. It turns out that the graph engine has become an indispensable part of the graph database of many, many people's efforts. It wasn't the first time people had talked about using this, but we actually used it as the core for many of the tools we built around there. Tools that included everything from image annotation tools to social network analysis. And again, back in 2002-03, building network analysis to look at the relationships between authors and topics and the availability of an open repository, the ePrint store, gave us a kind of a synergy, a form of opportunism that you wouldn't have gotten anywhere else. We were actually able to build. I still look at some of these systems and think they pointed to a really interesting form of clean engineering and data engineering. They allowed us to experiment at scale, to demonstrate at scale, and we began to see how network analysis, well, we were doing our own repository. Of course, not many years after, Google Scholar was doing it at global scale. And it's interesting again to see the kinds of problems that we were engaged in then. I remember we were at the time delighted to have access to what we thought was a huge amount of collected metadata about publications. Our colleague at Penn State, who built Lee Giles. I remember bringing the tape back on a transatlantic flight with the harvested content that he had at that time. Sightseer, I think it was the system. And around about that time, ACT was sufficiently interesting that Tim fell to talking to us about it, wanted to see what the art of the possible was. He was at that time promoting the semantic web, so the idea that data at web scale could be integrated just as documents were. What were the formats you'd need? What were the representation languages? What would you need to do to engineer that? And he saw in Southampton a absolutely serious effort to realize many of the aspects that he saw to be important in the semantic web. And it was. At the same time, we got this massive injection of support and funding from the eScience programs. Again, Tony leading that effort, that national effort. It looks, as you look back and see what was being done in 2005, 6, it's really, well, it was ahead of the curve, you might say. Everything from a system, this is a project that we were doing jointly with Mike Brady at Oxford at the time, where we were trying to integrate patient records, a whole range of different media types through the agency of a RDF3 store to provide reasoning services over that, to do things like annotating X-rays, mammograms in this case, to do automatic detection and identification. None of this led to large-scale deployed systems. Components of it survive and are regarded as being state-of-the-art even now. I mean, in particular, the mammography systems became, the image distribution systems became a key part of NHS's capability. And I think the improvements in bandwidth and processing power enabled all sorts of powerful integration to happen, which we imagined and which we demonstrated in our feasibility, in our conceptual realizations of these systems 15 years ago. And one of the other things that happened then is that we saw the opportunity to exploit some of this in startups. Again, Southampton has this long record of encouraging and supporting startups. I mean, the work that Gopal's doing now, but goes back, this is the work we did in Garlic, Tom Ilube, a whole bunch of people engaged. Steve Harris was employed in that project, Misha Tuffield, people who have been our postdocs, in building a system to actually this time we thought the challenge was identity theft. So it's a large-scale attempt to indicate where personal information was being compromised on the web. Ultimately, this software went inside the firewall that is Experian, and as far as I know, is still being used at scale. Yeah, there is. The other great thing that happened out of ACT was the work we did with the Office of Public Sector Information, Carol Tullow and her group. This was the beginning of our involvement in what became known as the open data movement. At the time, again, back in 2006-7, this was a small-scale project to illustrate that you could use semantic linking as a way of integrating diverse data sets across a whole range of government authorities. Really exciting work that ultimately led to us being engaged by the Labour government of Gordon Brown to kind of bring this to fruition at scale, opening up government data, the gov.uk, data.gov.uk site, which of course recently has been very much a place where COVID data has been made available, the data available for that. Interesting to see how that has all panned out. Ultimately, it led to the establishment of the Open Data Institute. Early on in Brown's government, we thought it was going to lead to the establishment of a Web Science Institute, in fact, announced in the budget and then taken away swiftly by David Willis when he became University Minister and Science Minister in the coalition government. This is an interesting 2013 G8 meeting with Putin and Cameron and Obama. Putin at this stage, the Russian Federation was doing work in the area of open data. In fact, we've given talks to the Chinese Communist Party on the use of open data. And actually, lots of regimes of different types and stripes are interested in linking data, making it available if they've got a clear idea of what data they'd like to make available. The real challenge is well, what if it's data that is more challenging to you? We're seeing something remarkable happen at the moment in Ukraine, which is the use of open source intelligence to bring optics to the way things are playing out there. That would have been, I think, incredible to imagine. And certainly, I don't think this guy is quite behind the Open Data Charter in the way that he claimed he was back then. But there you go. Yeah, so the open data movement, very much again in the spirit, I think partly informed by this ethos, going back to an earlier open manifesto around publications and open access. It's no accident that these ideas emerged here. And it was an exciting time. Somehow 2006 was this kind of year when so many things were happening. The open data work with the Office for Public Sector Information laid the foundations for stuff that became commissioned in 2010. Discussions around the web science effort, the need to try and broaden our discipline to re-engage in a disciplinary fashion. And a number of publications at the time were trying to lay these foundations, argue for this nexus of interconnections. And again, I remember us working together to kind of pull this together, which may seem all sort of mother and apple pie now, but it was trying to remind people, whatever you call the successor to those ideas, whether it's network science, web science, whether it's computational sociology, the idea was to look for a enrichment of methods by not believing that one methodology was sovereign. We also recognize something that's become very relevant recently. How long have we been talking for? 10 minutes, 15 minutes? Nearly all my time. Whereas the issue here, this is Google Flu. Do you remember that? This is where people suddenly realized at scale data could be insightful, that trends could emerge. Subsequently, there are all sorts of reasons to worry about whether that simple association is as straightforward as people thought. But what we all realized at the time was that Google had all the interesting data that we needed as research communities to interrogate, to analyze. It's exactly the same challenge we're facing now with foundation models, very large-scale models being used in AI. We still need new forms of research alliance. We still need new forms of data access. Many of these challenges continue. Back then, I was also interested, still am, in neuromorphic computing, work I do with my colleague Terry Elliott. But this was the area where I link up. Given Nick's talk, the thing that I was putting together and working on in my later years here with colleagues was this whole idea of social machines, which Nick would recognize as human agent partnerships. It's interesting, I think, that we had different ways of framing the same issue. That was a program grant that we won, doing really interesting work, again, on large-scale data analytics to understand everything from traffic shaping on the web to supporting citizen science. Chris Lintott's famous work still ongoing in Citizen Science Universe and such like. Also, interestingly, a collaboration with Jacek Brodsky on topological analysis of data, which has become a huge area of research now. In fact, topological algebraic kind of formulations in general are receiving a lot of interest across a whole range of computer science, but that was some of our early work there. On moving to just kind of sort of round off, the work in Oxford has clearly been hugely influenced by, well, the second half of the Socium project was run in Oxford. The work that has continued through, in some sense, interestingly enough, the whole story around data concentrations and data monopolies. This is work we did on analyzing data flows through ad tech in our mobile phones. Made some of our tech platforms very unhappy, but it was quite clear that there were huge challenges around competition, and the CMA got interested in this competition of markets. How can you regulate if you've no sense at all of where the data flows are and where the concentrations are when company X acquires company Y and suddenly there's a super concentration. Markets don't work always without a good insight that needs a degree of oversight and regulation. The whole issue around ethics and work we did on a bunch of projects, again, there's so much richness here. The global challenges that were set by computer science, by Tony Hoare, Rob Milner, sort of kicked off this whole area. We were looking at things like memories for life, the whole idea, what would happen when our entire life memories were in a sense being harvested and sequestered somewhere, and whether it's a smart toy or it's the device in your home, there are real challenges to deal with here. Or the susceptibility of particular parts of our demographic to challenges here. You know, how does a young child deal with their sense of privacy and self-determination in this world? Which really kind of moves to the fact that a great deal of the challenges have this ethical dimension. And most recently been worrying about the whole problem about equity and the properties inherent in these very large-scale AI models that are being proposed. Who has access to them? There are probably 6 consequential ones in existence, and one of them we know is rather good at answering essays. GPT-3, or indeed its successor, was actually, we put it to work to try and solve the All Souls entrance exam. That's the question. Is the Turing test a reasonable criteria for the achievement of general AI? That's the completion. It's not entirely implausible. It's an extraordinary, and I know that people here have been worrying about exactly that challenge in terms of how you deal with genuine human authenticity, which is perhaps, therefore, not surprising that the thing I continue to do with my colleagues now in Oxford is think about this more ethical set of architectures. The work with Tim continues in a project we call Ethical Web and Data Architectures, where we're looking at the use of decentralized architectures as a possible antidote to platform concentration, things like Solid. Colleague, of course, who used to be here, Max, now a professor, and Rubin, both of them lecturers, professors, I should say, in the department. And this old chestnut, ethics, spent a lot of time trying to establish within the Oxford ecosystem an institute for ethics and AI. Actually, interestingly, it's located in philosophy, where historically great ethical work has been done. And there the challenge is making sure that its insights permeate out to the wider university. So there we go, all of those issues. I know it's an item that has become very high on the agenda in many areas, many departments of computer science. And are there any photographs? There are a few. Somehow all of this was fueled by healthy amounts of alcohol and social interaction. This is possibly a real keeper. This is Robin Milner, of course. This is a keeper. the Robin Milner photo with Carol and you. That's Milner. Yeah, one of the great theorists in computer science, after whom the Royal Society's Milner Prize is named. You know, this is but he had a. Well, anyway, there we go. Good old Hugh. This was actually on the same bus trip out. This is Aberdeen, I think. There really is nothing. No, I shouldn't say there's nothing else to do in Aberdeen. It's a wonderful place, and Tim enjoyed it for 17 years. And there he is. Yeah, and you can see what Nick really thinks, gazing wistfully into my eyes. Tell me all you know about human interaction. There's always a flip side. Actually, when you travel on a lot of 30,000 feet with Wendy for a lot of the time, you'll often catch her in a moment of repose and contemplation. It's a feature. It's a feature. There they are. I have a whole list. In fact, the most excellent one of all, I just have misplaced the moment. It's Tony Hay in the back of a taxi in Seattle. Yeah, slightly. Yeah. Anyway, we were. But the truth of it all is that it's been wonderful to be associated with this great department. That was one of our get-togethers late in the day down at the oceanography department, where we had an away day. Good old Luke kind of effectively ran the entire show for me, because I was, although notionally kind of meant to be doing something leadership, it required a dedication and time on task. And great DPhil students, great postdocs, Kieran, Harith, Misha, Paul Smart, a bunch of people who worked on the Socium Project, Max and Dan and Laura, and that's Ramin, I think. That's Ramin and Marcus. So, and many more, many more, too many to list. There is a deep, deep history, oral, written. Sometimes the cognitive revolutions that Stephen was talking about, some of this stuff is there, not all of it is. Because the other thing you have to be careful with, it was something that Hugh said, is that just because we say it was so, doesn't mean it was so. So we also need to recognise there are always contesting, contrasting histories in all of this, and people will see it from different viewpoints. So collecting those viewpoints, hugely important. It's been a pleasure. Thank you.
I want to be asleep on the plane. I haven't seen that one before. Shocking. Right, Nigel, thank you for that. Memory lane, amazing. Ideas research came out of time here, and they carry on. Now, welcome to Muffy, who's just arrived. To see the picture of me and Robin Milner, I bet that was a shocker. I don't remember that either.
You never had to be like that.
What was I wearing? Now, young Michael here, I remember appointing him, or at least being on your interview panel, and then...
Tommy was head of department.
Yes, and then was it... I think your promotion panel was the one that we had Robin Milner and Tony Hoare.
I've got an interesting story.
Okay, so there's all right. So that's the link to Robin Milner here. How can, you know, obviously I've known Michael a long time, and it's been a pleasure working with him. Now, of course, he's my boss, which is absolutely amazing.
You've got your present coming up.
I know, November the something. Well, you can talk to Tony about what it's like being my boss. But anyway, yes, I'll look forward to that, Michael. So he's now, you know, Dean. It's amazing, and it's fabulous, and of course we hugely respect. So I asked him to say something. Of course, he's been one of the leaders here in his work on formal methods and the group he runs. But also, I want to finish with the where we're going in the future, and this again points to Paul there sitting in the audience, the upside of where we're going with the huge investment in computer science. Michael, take your time.
So the influence of Tony Hay on various careers has been a recurring theme event. So after I was interviewed for a lectureship at Southampton, I was also interviewed at Warwick, and I was offered both Warwick and Southampton. I decided I'm going to go to Warwick because they'd done better in the RAE at the time. Tony phoned me up, gave me a long spiel explaining that Warwick had peaked and Southampton was on its way up. And I bought it. So I decided to come to Southampton. Who knows whether it was the right decision or not. For the uninitiated, oh yeah, by the way, the reason I chose this title is because every time I meet Tony, he says to me, oh, you still doing formal methods then? So 25 years later, we had an impact case study on formal methods in Ref 21, and we got a 4-star for it because we know that because all our impact case studies in computer science got 4 stars, which is a fantastic achievement, and something I'm really proud of. Of course, I didn't do this in order to get a Ref impact case study. It was really because it's intellectually rewarding and challenging. So for the uninitiated, formal methods in a nutshell, Dijkstra told us that testing demonstrates the presence, not the absence of bugs. errors in software. So how do we demonstrate the absence of errors in software? And that's what formal methods is about. So it's essentially treating programs as mathematical entities and proving theorems about those programs, in particular proving correctness of theorems, proving typically that they satisfy some specification. And what people realized is that the specifications themselves are interesting mathematical entities, not just the programs. In particular, it allows you to write more abstract specifications, specifications that are closer to the requirements of a software system, are closer to how you might understand the system from the point of view of the users rather than the coders. So that gave rise to concepts of formal specification languages, and in order to bridge that gap between a more abstract specification and a program, notions of refinement were developed. So this slide is perhaps the most important one for today's talk, a little bit about my formal methods journey. So way back in the 1980s, I did an undergraduate degree in computer science in Trinity College Dublin. There were 33 students in the class, by the way. 11 of those were women. Those ratios have overgrown since then. And for my final year project, I developed an animator for the Z specification, which I mentioned these mathematical specification languages using Prolog. Tony mentioned Kix earlier today. So Kix, one of the first industrial uses of the Z specification languages was a specification of the Kix transaction processing system. It won a Queen's Award. I wasn't involved in it because so Z was developed in Oxford. And that's why I ended up, I guess, doing a DPhil, as they call it in Oxford. When I was in my final year, I was trying to decide whether I wanted to do a PhD in AI and go to Edinburgh, or a PhD in formal methods and go to Oxford. And I concluded that, because then it was just expert systems that that's what people were doing in AI, I concluded it just couldn't scale. So I decided formal methods are it's addressing a much more important problem, which is software correctness. It was great to hear from Nigel that actually it can scale. It took some time to get there, and yet another interesting decision point in my career. Who knows whether it was the right decision or not. Formal methods, it has to be said, is still quite niche in industry. It's not true of AI course these days. However, as you can see, it led to getting a good, successful career and continues to do that. So in Oxford, my thesis was around linking these refinement-based approaches that I talked about. So in Z, you represent or model a system by describing the states that the system can be in, and describe constraints on the state space by what I call invariants. Whereas in what I call process algebra, it's like CSP, or calculus, brought from Roland Miller, so CSP was from Tony Hoare. You describe a system in terms of the interactions with the system and composing systems and decomposing systems. So I linked those two worlds. Then I ended up doing a postdoc in Finland, working with a guy called Ralph Back. He was the person who first formalized the notion of program refinement in the 1980s. And at the time, he was very interested in higher order logic. Those of you who know about that, so it's programs or reasoning about proving properties. Robert Milner, again, was one of the founding fathers of higher order logic. And then, as I said, I came to Southampton, not Warwick. Around that time, I met up with a guy called Jean-Laurent Abrial, who actually was one of the developers of the Z notation. but then went off to work in industry, and he developed a better form of method called B. Better because it's a tool. It's easier to build tools to support reasoning about B specifications, and it really took off in industry because of those tools, but also because it's been used a lot in railway system development, so developing software for railway systems, particularly in France and Germany. And through Jean-Marie Abial, I got involved in various EU projects, which was a real privilege to get that invitation, and that really helped accelerate, I would say, the work, the research work that I was doing. So I got involved in doing various industrial applications. In the early days, I was working with Peter Hartel, so some of you remember Peter Hartel was here, worked closely with Hugh. So Peter was doing work with companies to develop smart cards, so we did some work on applying the B method to proving properties of smart cards. Initially I didn't do much work with Peter Henderson. Peter Henderson was head of group that I joined when I joined Southampton. But actually Peter, I would say, had a lot of influence on me. So he mentored me really well, and particularly encouraged me to do work with industry, and made me realise that actually just doing work with industry, collaborating with industry, is itself very rewarding. And don't worry too much about getting the publications, because they will come later anyway. Doing that work and trying to address problems that people in industry have. And Peter really influenced me and supported me in doing that. But I also then started, because he was doing work with IBM and Kersley on long-running transactions, working with Peter on modelling, formal modelling of long-running transactions. And for that work, I didn't use B or Z. I used operational semantics, which is closer to the work that Sir Robin Luna was mentioned that he does. And then, so we developed a formal semantics for what we call compensating CSP. So that's CSP, a version of CSP that has the notion of compensation. So it's a way of undoing effects in a long-running transaction. If you decide you've gone through certain stages of a transaction, like an airline booking or something, and you want to abandon the transaction, instead of undoing, you have a notion of compensation. So I was working with Peter Henderson and people at IBM that led to me developing this sort of variant of CSP, compensating CSP. And then I, at a workshop in Cambridge, was explaining this to Tony Hoare, and he really poo-pooed the use of operational semantics, because we're from Oxford, the semantics you should be using is denotational semantics, and that's describing a system in terms of traces of behaviours over time, sets of traces of behaviours. And at the time, I tried to persuade him that it was too difficult to do for the kinds of behaviours we were describing. But we had to do it for over a few months. And because Tony does this thing, he tests you out and drops an idea and sees how well you responded to it. Luckily, I responded, so we developed what I think is actually very elegant case semantics for compensation. And that led to the interesting story about Tony and Robin, because when I had an interview for a chair here at Southampton, both Tony and Robin were on the interview panel. And Robin very mischievously asked me to do a comparison of bisimulation semantics and trace semantics, because Robin is a bisimulation semantics person and Tony Hoare is a trace semantics person. I can't remember. I panicked. But at the time I was writing a paper with Tony, so I think I came out slightly in favour of using trace semantics and the benefits. Michael Eichel, who joined Southampton just not long after I did. So Michael Eichel worked in constraint logic programming. So there's a link back to my undergraduate project. And by the way, so when I was an undergraduate, we had access to a VAX didn't have PCs, and we had 5 minutes CPU time per week. But simulating Z specification of telephone exchange very quickly used up my my 5 minutes. So that helped sort of interfere with my project a little bit. To the extent that while I was doing my PhD, the only software tool I used was LaTeX. Pretty creative with very nice theorems and proofs. Another nice connection with Southampton, funnily enough. Sebastian Ratz. So Michael Eshel came and he got interested in the work that I was doing with this B language and trying to prove things, and tried to persuade me that constraint logic programming would be a good way of doing model checking. And I pointed to the work that I did for my undergrad, and it just won't scale for the kinds of state spaces that you want to reason about. But I was wrong, he was right, because he uses in constraint logic programming some really clever optimization tricks that allow you to explore quite large state spaces. So I very quickly realized that I need to work with him rather than against him, because I was trying to persuade him what you need to use is automated theorem proving. So automated theorem proving allows you to reason about infinite systems, infinite state systems, using finite number of symbols and finite manipulation of symbols. Whereas using model checking and using Prolog, you're effectively executing, computing a state space. Right, the other thing, what I found in working with industry is you talk to some people and they say, well, we like using UML. So UML is like a graphical, and if you will be familiar with UML, graphical language for describing, for modeling software systems, state machine diagrams, class diagrams, and so on. So with Colin Snook, who came here to do PhD with me in the early 2000s, we developed what we call UML-B. So it's essentially a graphical version of B. So B is I haven't shown you any B yet. B is a mathematical language. UML-B is like a graphical representation of some of the aspects of the mathematical language. And we found that was a really good calling card in building up collaborations with industry, because they can relate to it much more easily than maths. And it's those two concepts and our tools that led to the impact case study in REF. So the ProB and UML-B. So it's been used, ProB has been used quite a lot in railway projects in France and Germany, and by French and German companies around the world. So,
probably.
You're the dean, just
yeah.
We've got muffins left to do.
Yeah. Right. So very quickly, so UML-B probably those were really key. At the top there's some tools mentioned, B-Toolkit and Atelier-B. So those are commercial tools. B-Toolkit does not exist anymore. It's a UK company. Atelier-B does. It's supported and licensed by a company based in France. We were working very closely with that company, so myself and Gabrielle. But the tool was very closed, and the company wasn't very open to adding new features to the tool. So we developed an open source tool called Rodin. And it's called Rodin because the first EU project that we had that funded the development of that tool was called Rodin. It stood for Rigorous Open Development New Environment. And that open source project tool has continued. It still continues. We've got a reasonably strong community, mostly European, but some people in Japan, China, South America using it and contributing to that as well. And so the Pro B, UMLB, those tools are all features of Rodan available within Rodan. And having the tools open source, again, was a really good calling card, because it's talking to some companies and they don't have to worry about license fees. But also it allows us to experiment with new tool features, and quite a lot of my PhD students over time have contributed plugins to Rodan, experimental features, so we could have both a core industrial strength version and then add experimental features. I'm going to have to skip lots and lots of slides, and you see, I did have some. I was optimistic about how much I would be able to get through. An interesting story about this. So this is the stuff in blue at the bottom is a piece of a B specification, and I was giving this talk to a group of industrial senior managers in an automotive company in Stuttgart, because we had a project with people, and they really wanted us to sell performer methods to their managers. And I was being really careful not to, so I wanted to show them a little bit of mathematics, but I also would have an English description of what it means. And I do recall that this particular invariant, the most senior manager stopped me and said, so I don't really understand what this is saying. And I said, no, I don't want you to understand it in detail. So have an English, because I also had an English description on the same slide. So as long as you understand the English description, that's fine. But he said, but I don't understand what the square brackets mean. I said, well, that's relational image. I said, thank you, now I understand it. But that tells you something about managers of German engineering companies. Right, so those are screenshots of the Rodan tool. You see these green things are all theorems that are mathematical theorems that are automatically generated. And if you do it green, it means the theorem has been automatically proved as well. This is an example of UMLB. So this is a state machine, a graphical representation. Our UMLB tool will generate mathematical representation of that, and then we can prove theorems about it. We did some work for AWE, which is it's an additional front end, which is for hardware software co-design. So some of these basically have this system consisting of combinations of hardware and software components. So we developed a tool where they can use for designing co-design of hardware software systems. But it's built on top of Rodan, so they can prove theorems about their models as well. And this is work that Thales in Austria have done, again using in this case, Pro B as a front end to animation and prove things about. Let's go with that. And that's just some of the nice things some of the companies said about our tools in for our F impact case study. So, for example, the first one, these kinds of numbers are nice. So using Pro B, they were able to achieve 100 times, achieve verification that was 100 times quicker than their normal, and that saves them obviously a lot of money. Right, this is my last slide, Wendy, and this is what Wendy asked me to talk about as well. So taking my computer science hat off and my D hat on, I think Wendy alluded to the fact that there were glory days, and then more recently we started to go down big tables in computer science. That was large, partly because there's some great people leaving who've come back to us today, but also basically unplanned growth in student numbers, because computer science is slow. So we said we have a big increase in intake into computer science without the investment in new staff. That's all changed now. And I have to say that I have to stop calling new vice chancellor. So Mark Smith was a vice chancellor. who came in 3 years ago now, really, I'd say, recognised the issue and was very supportive of an investment case. Although in this here, I'd really like to thank Paul for his effort in helping us put together the case. Steve Dunn, who's not here, did a lot of work as well to help us put together that case, and other people. And actually, we put together a case that was a no-brainer and was accepted. Now we'll be going through the process of hiring those people. So just to put some numbers on it, we got some agreement to appoint 24 new academics in computer science last year. That's doubling. That's going from basically increase of 50% in the number of academics. We're going through the process of hiring all those. We've been very keen to do what we can to use this as an opportunity to increase the number of women in computer science, and I would say we're having good success there. I don't know, Tim, Paul, if you have the numbers to hand out.
So in the last 18 months, a third of our appointments.
Yeah. So that's really positive. The other thing that's, of course, really positive is the university recognises, so whenever I'm in senior leadership meetings, there's always a question about AI, data science is really important for this multidisciplinary research. So that's recognised, and the work that some of our speakers have already talked about, so the great multi-interdisciplinary approach, and the people here have worked with social scientists and medics and others, and that approach is very much part of the university strategy and is being supported. And so I see there's a really strong future for ECS, computer science and electronics in Southampton. So there are new programs being developed and new multidisciplinary areas being developed, particularly in health, but also in net zero. So it's very much on the up.
Thank you. Right, so we don't have that. Thank you, Michael. That was, and thank you to Paul again for leading us back into future glory days. Our Regis lecturer has arrived, and I'm going to ask you to. We'll do the photos before your lecture. There isn't a lot of time. There's refreshments outside. I was going to say something else. I wanted to say, and could you pass this on? Thanks to the admin team, who, it was WSI team who did this. Paul was saying to me, we really ought to have a CS event in the ECS 75th anniversary year. So in the end, I ended up organising it, and the WSI admin team pulled it all together with help from Adrian and Joyce. The whole point of this is to archive the history. That's why I'm running a history of the web track at the web conference. This stuff just disappears once you go digital. And so it's really important to keep this going. And of course, we are a CS in ECS. The E keeps going from strength to strength. So it's a fabulous department to belong to. And thank you to all of you to come in this afternoon. Go take some refreshments, come back in, and we will live stream our inaugural Regis Chair lecture. I forget which round the words go, but you know what I mean. Thank you, everybody. Thanks, all the speakers.